it's a PDF, and you can see there's a table of contents. The first, this is like a 2-page spread here. So there and there, and then this one. And you can see in the table of contents, the different things it points to, but there's these little red line areas that are pointing you to specific exercises, okay? And also, if you take your mouse and click on any one of those, these are all hyperlinked, so they will jump to that section in the manual. Except there's nothing here that says go back to the top. You would just have to, come back up here and choose to go back, or up in your PDF navigation tools, go back to the top. So, if you're using this in the future for reference, keep that handy. You want to look something up, you can do it that way. You don't have to count through pages. Now, that being said, too, the way this class and this structure is organized, the fundamentals class, which is a 2-day in-depth immersion into the class, it spends a lot of time on concepts like organizing the work, these directory structures. We're not going to spend all that much time on them. You probably got them under control anyway. We'll talk about some of the things as we need to, okay? And like where things are generally and how to sort of think your way through menu structures and such. Talk about points and point groups, if you do or do not use them very much on your own. Again, most civil people tend not to bother with them. Most surveyors can't even draw a square without traversing their way around COGO points, by set up here, backside there, turn a 270 angle right, and set the next point. And that's fine. That's not meant to be a bash on a surveyor. I'm also a surveyor. So, but they tend to think in terms of points, and that's perfectly legitimate, perfectly fine. You can do things with or without, heavily involved or little involved with points. So if you do have a lot, and we'll talk about a little bit of that, just so you're aware of how they work and what can be done with them. And there's a couple of little tricks, like this is one of my favorite exercises on drawing the pin locations on all the corners of a subdivision plat. It's pretty slick little tool, little trick. Now, then the surfaces and contours, and this right here, terrain modeling, is the core concept behind everything you do, not only in Carlson Civil or in survey, but in any type of 3D design software, whether it's Civil 3D, whether it's Open Roads Designer, whether it's micro survey, any of the commercial products. You need to be able to think about what happens, how the computer is modeling these conditions, and our role as designers is to basically come up with a condition that is expressed in relationship to a prior condition. So we're coming up with a design surface. We have an existing surface that we're designing against, because we don't know how much to dig or how much to bring in and pile on top of. That's very simple approach to what we do. So this, starting here on page 18, whoops, let's see, back to it. Yeah, starting here on page 18, which was, I was thinking it was over here. And that goes through, I'll just take you through the pages. There's 18, 19, 20, 21. And this shows you, some of the processes and some of the error conditions that you could run into, and some ways to evaluate whether or not you modeled things correctly, and what's going on behind the scenes. We're building triangles. We're going to be working on those triangles. How do we visualize those to confirm that we're doing things correctly? And I think once people understand those concepts and tools, it doesn't matter whether you use Carlson and whether you're a person who likes to go through and you build a surface and then you like to edit the surface by swapping triangles and finagle around points of the terrain model, or whether you like I do, I prefer to go back and fix the problem with the data that caused that to happen in the first place.
Yeah.
Because to me, that's always more recreatable if I do it from that approach. Anyway, so that's the biggest concept of that fundamentals class. And then it goes on to see, I guess we're into the exercise at that point. So yeah, it goes right down through here to where it starts with this exercise of adding break lines, and goes through several things, how to use the 3D viewer, all of that. Well, anyway, when it gets all down to that, let's come back up here now. And that was this adding break lines. Then we have some surface evaluation tools. And then we have this little exercise called putting it all together, where we're going to basically take just a bunch of points and step through a process of taking those points, turning them into usable objects in our drawing, creating a terrain model from those, which is basically a stockpile of materials. We compute some volumes. We then go to, we design a borrow pit out of that stockpile. Okay, and then how to merge all that stuff together. And here's, for instance, that's the rough borrow pit in terms of a terrain model. There's the borrow pit superimposed on or excised into that existing model. And then what we want to do from there is to come up with a access road following, say, along this green alignment. That's going to be our haul road into that borrow pit. So we want to come in on the ground down here, come up and land on the ground right in here. This is our existing grade. Like so. Here's where we start on the ground. We're going to end up on the ground. We design the vertical through all of that. And then what do we do with it from there? Now, this particular exercise takes a slightly different approach. If you're not, this is meant for like people who don't have the survey or don't have the civil module. You can still do all this with survey, which is the basic level module that most people may get. So you can come up with these designs here, and then you can wind up with creating this little, look on this left-hand page, that center line, that center blue line, that becomes a 3D polyline. And then I'm going to offset it to the left and to the right to make these edges. And I'm offsetting it over a certain distance horizontally and down a 2% slope for my crown of my road. And then I'm going to take those edges and I'm going to go out and seek that original ground. And I do that with, I can do several tools that I can do with that as well. And so then I just come up with basically this little terrain model of that, how it ties into the existing grade. And let's see from there.
So I'm guessing because of the simplicity of this particular example, simplicity of that road, you're using the 3D polylines and the 3D offset vertical
Yes.
offset, because instead of using a road net.
Right. Right, but the reason is not because it's simple enough that that's the easier or better way. The reason is for some people who don't have civil, maybe they only have survey, they don't have access to RoadNet. So that's what I was getting ready to say. In this regard, this particular exercise is, very simplistic, but this is exactly the same. If we go down through the end of this, putting it together exercise, that's the end of the fundamentals class.
Okay.
Yeah, and at this point is where we pick up civil. And here's where we get into actual real road design with, material layers and structures of subgrades and things like that. And we use RoadNet or even, the road design tools individually, and then how RoadNet puts them together. Okay, and there's some really useful things, and like this particular data set that we're going to be using is going to be, it actually comes, it's a Civil 3D file, and we're going to see how we pull out a terrain model from the embedded Civil 3D 10 that's part of that DGN. Carlson has tools to go in there and find those and pull them out and make the external files. So, which you may be aware of or not, but and then
somewhat aware of it, more so that Carlson does not the Civil 3D stuff does not interact well in the regular AutoCAD environment. Again, more due to lack of understanding of how to properly convert or extract that information for when we want to use it in Carlson.
yeah, I think that's a fair assessment. And I think Carlson is working toward, and I'm not really sure how far along they are with that, but they're working toward being able to work with a Civil 3D DWG surface, which is embedded in the DWG file. They're working toward the state at which they're going to be able to work with that, just like we do in standard native Carlson surface modeling, which is all external files, but to be able to keep them as internal objects as well. I'm sort of philosophically against that approach because to me it's, and I understand it. It makes it convenient for people who don't want to have to maintain two separate data sources.
Yeah.
And the goal is to also make it interoperable to the point where it doesn't matter which tool you use. But the problem is that it removes the user one level from controlling that data, I think. And then you've got the problem of what happens when your DWG file goes belly up, when you've corrupted the file. Well, there goes your data. Whereas in Carlson, you can lose that DWG file and recreate everything from those external files. If you've got, alignment, you've got profiles, you've got points, you've got parcels, you've got terrain models, you can recreate and redraw every bit of that drawing that you need.
Yeah.
Based on that data. So anyway, we won't dwell a whole lot on that, but the concepts are going to be there. And you're also going to see, now, I don't know that I've got anything in this data set to illustrate. I've had some with some of my clients where sometimes, and it's particularly around edge conditions of bringing Civil 3D surfaces into Carlson stuff, you'll get some, I don't know, they're not translation issues, but they're things like cases where that they will, in one direction or the other, where it's usually coming from Civil 3D into Carlson, it will disregard the surface boundary.
Okay.
And you'll have to recreate that. But I mean, there's tools that make it easy enough to do that. So there's still a couple of little glitches, not 100%, but it's really pretty complete. And it not only does it with Civil 3D, but Carlson worked with all of the Bentley, the MicroStation files as well. And in fact, Bentley, the Bentley folks were so impressed with particularly the surveying tool sets in Carlson that several years back now, they sponsored an entire summer where they basically had an exchange program that the Carlson programmers went to work for Bentley, learning all about their data formats and how they did things. And they sent Bentley programmers to Carlson to see how, not the whole programming team, of course, but, just a few, so that they could come back. And the goal was to be able to share their data at a much more intimate level. And, which was like the opposite approach, because Autodesk doesn't want any possible competition from anybody, and they'll fight tooth and toenail to keep it secret. So, they and Trimble, they're the ones that sort of keep the industry held back, but I digress.
Yeah.
Anyway, um, so like I said, what we'll do here is we're not going to spend a lot of effort on, trying to figure out how to build this this road design based on the taking a 3D polyline and offsetting the edges and doing all of that, because we're going to do that with things like when we design, say, a parking lot, and that might be the back edge of a curb. Well, then how do we step it down, to the face of the curb, down to the surface? Or then how do we take it from the back of that and tie it into the existing ground? That's the very same exercise. We don't need to do our road design. The road design, if we have civil, is a lot more efficient and simpler and easier to understand using those tools. And whether we use RoadNet or whether we simply use road design tools, and really there's no difference. The only difference is that RoadNet ties all of those tools together so you have access to them in a single interface.
Right.
So they're still exactly the same type approach. All right. So that's what we will work on, and then we'll get into that tool from the civil parts of the design. And let's see what we have here. We have that was the putting it all together, and that ended. Oh, excuse me. Oh man, excuse me. I don't know where that came from. So that ended the same thing that the fundamentals class covers, and the material in the book and the exercises are exactly the same, but in fundamentals we'll really go deep into some of these things. I think you've probably already got the things that we try to teach in that, so we'll gloss over those. But that being said, anytime I'm talking about anything that's new or I blow past something you don't understand, interrupt me so that I can make sure we get it covered. Don't say to yourself, oh, I'll catch it later. If it's something, it may just simply be something you haven't seen yet. It might be a simple, fundamental, early on concept, but maybe you've just not encountered it yet.
Right.
That's what we want to try to remedy, is to fix those holes. So anytime I'm going too fast or you've missed a point, yell and say, hey, what, how did we do that? I'll be glad to back that up and cover it. If, on the other hand, I'm dawdling around and spending an hour and a half on something you already know how to do intimately, then, tell me, let's move ahead. I got that. Okay.
Yep.
All right. So then, so after we finish a couple of things, we're going to not gloss over, we're going to step through a couple of these things, but not the whole fundamentals class. And then we come to the civil part, and the two things here is the single roadway design. And that was where we start talking about here and the things that we need for road design. Of course, that goes through a number of concepts, but then the next exercise are these grading tools. And then that talks about, we're going to design a pad, and then we're going to balance our cut and fill and do some site grading. And then when we do that, we've got a little building here that we're going to use to make a building pad, and then we're going to build a parking lot next to it. And then we're going to come from that parking lot into, we're going to connect it out into this main roadway that we designed through our site. But the key thing that we're going to get a chance to look at here are some of the intricacies involved in grading design. So here's a parking lot that when you take the parking lot by itself and tie it into the existing ground, and you take the building pad by itself and tie it into existing ground, sometimes you get a condition like this. Okay, whereas the building by itself tries to come up here and catch the ground. The parking lot here does the same thing, but really you don't need that raised hump there. You just basically need to go edge to edge. and eliminate that ridge.
Yep.
Okay, so how do we go about taking care of things like that in this area here where there's a little bit of spillover?
Sure.
There are some tools that help us. There's one called multiple pad design that's part of the design pad template, which yes and no sometimes does and sometimes doesn't exactly work. It depends on how tight you get into things like this. But once you are able to see these things and visualize them, and then know how to resolve that, go about constructing the actual surface. And like, to simplify this concept is that these lines that you see here are drawn 3D polylines, and they're all part of that design pad. They've already been turned into a surface potentially.
Yeah.
But I can take this ridge line out. I can break that border, clean that out, and just go edge to edge and let that form its own surface. But I need to then take all of these drawn lines and their boundaries and create a composite surface and then merge that back into my existing ground. So it's just understanding that workflow that we're going to talk about there. And then of course the road design, and then we talk about road net, how it handles intersections and cul-de-sacs and such like that. So we'll look at that. We will not most likely get a chance to do any kind of stormwater design or assessment. That's really, we actually have a separate class on that. That's not why I'm saying we're not going to do it. I'm saying because we just won't have time.
Okay.
But the hydro module is the one that has most of those tools in it. There are a few tools here. You can certainly design pipes and locations, and part of the RoadNet tool set is, let me go back where I just was here. Yeah, so I say, for instance, at the bottom of this sag curve, you can have RoadNet say kick out the low point of the profile as it is along the face of curb or back of curb or edge of pavement or any type of point along that cross section. You can have it automatically generate Carlson points. So then you know where your inlets need to be placed. Right. So there's some tools like that that can help us, but we won't really get into a lot of stormwater design. Now, once that is finished, we're talking about, the grading and the road design. The rest of the manual has these tools, and it's in the section called command reference. Let me go back up to the top and contrast a couple of things. Up in here, we have a little section that says what's on the menu. It's over on this left-hand page, right in there. And it talks about general versus modular menus. So, and here are the general menus, file through points. Every Carlson module has those menus. And then the modular menus are depending on what module you are in. If you're in civil, you have the set of civil menus. If you're in survey, vice versa. Trenching, construction, geotech, GIS, all of those different things. So what this part of the book says, even though there's a lot of entries on my table of contents, you see it starts on page 7 and it goes all the way over here. It goes through page 9. It's only 2 pages worth of the manual is what we're talking about here. The general file edit view, drawing query settings and points, that just simply says that. And then this speaks in general what is on these general menus. The file menu contains file commands, edit menu, edit commands. All right. So that is what is met up there by those commands. What they are. It's not explaining the commands. That is left to the part that is here at the tail end of the last grading or the last exercise, where it starts here under command reference, and you see that's general and then civil as well. So this shows you each of these commands that are on these menus. So a couple of things to keep in mind about this command reference is that can be helpful for you is that, first of all, these are in a lot of instances, simply, I wouldn't say simply copied and pasted out of the help system, but you'll see a lot of replication of information from the help system, because that's where a lot of that stuff was started from. So sometimes then you'll see um, that information either whittled way down because you don't need to have 3 pages worth of explanation, or it's expanded upon because you need a little bit more than what they gave you. So that was the intent there. And you'll see things like, when you see these little right pointing triangles, that brings up a secondary menu and that kind of stuff. Now, each section starts, here's the file menu. So that's the file pull down. You'll see a picture of that. And then here's some of the commands that are expanded or to show you where certain things are. And you'll see some things that are red and bold. Here's cases drawing cleanup. Here's an example over here, erase by layer. Now we're starting onto the edit menu now. But erase by layer, erase by closed, outside, but temporary erase, copied layer, multiple offset, things like that are not bold-faced and red. And the only thing that indicates is that in my experience, since I'm the guy that wrote the book, in my experience, those were the ones that either had the most functionality or the things that I find the handiest to know about and to use, even though I could figure out how to do all those kind of things just using standard CAD tools. That wasn't a big deal, but that I found a lot of good functionality in Carlson's versions of those commands.
Okay.
Now, the other thing that you'll see up here in this opening paragraph under the edit menu, it says, there's a lot of standard CAD tools like move, copy, trim, rotate, as well as those Carlson enhanced variations. And for this entire section on the command structure, if it is a standard Carlson tool like erase, select, erase, last, or whatever, you're not going to see it here. You're only going to see the Carlson variations. Otherwise, you're expected to know your own CAD command tools, and they're just not expounded upon here, because it also, those commands change sometimes with periodic changes in the CAD engine. So what you see here are the Carlson commands and how they work using those tools. All right, so you'll see all those, and it goes through all of those general menus, including, there's a couple of ones I want to point out to you here. Let me go back to the top on the draw menu. Now this is an interesting one because file, edit, view, draw. Draw is where you actually do most of your creating of different things. And again, there's some wonderful Carlson modifications to standard tools like drawing a polyline. A lot of CAD jockeys, they'll just type PL and run with it, or P line, whatever they may have the command. And that's fine. It creates a polyline, but you're not able to type in a point number or a range of point numbers if you use the standard AutoCAD command. So you want to think about using Carlson's version of that command called draw 2D polyline or 3D polyline, what have you. And when you do that, then you get these extra options that Carlson has programmed into it. So we're going to take a look at some of those. And most of that we're going to encounter as we go through the exercises. We're not going to go through this thing command by command by command. We just don't have enough time to do that, and it would be really kind of boring. So, but we're going to do a few of them. But here's what I also wanted to point out is not only do the Carlson equivalent commands, first of all, they do not get rid of any of the AutoCAD commands. You're not forced to use any of these Carlson commands, but they offer some advantages that a lot of people aren't necessarily aware of. Now, there's no reason you have to use them. You have to take advantage of them. But to me, a lot of times, it's the better, the more efficient approach to doing it. Now, the other thing is that there are some things tucked away in, and there are so many, you know, pull right sections and all of that kind of crap that it's just hard to understand where everything goes. And it's hard to sort of assign categories to things. For instance, right here on this page on the drawing menu, there is this command, okay, under the arc pull right menu. And if we see up here, it's up near the top, you choose arc and there's a pull right. It has a number of tools, but one of the things, and this is one of the little hidden gems, for instance, there's this curve calculator that's included in that under the draw menu. Now it lets you type in a radius or a delta angle, arc length, or however many things that it needs. When it has the minimum to compute a curve, it fills everything else out. And then it allows you for these buttons down here below to, if you have one that has been calculated, you can hit the plot button and it will draw it on the screen, or you can select one that's already drawn and it will populate these fields up here and read all that information for you. You can also just simply give it points, and those can be snapped locations like Carlson point numbers or the midpoint of a drawn line or 3D line or anything like that. Okay, so that's it's a pretty impressive little tool that is not readily apparent as to where that would be.
Yeah.
That's the draw menu. So I'm just telling you, there's going to be some things that don't make sense, that they're stuck away somewhere, but you're just going to have to, to sort of stumble across those when you get to it. All right. So that's going to go through all of those, and let me get to the, that drawing inspector. That's a really great tool that a lot of people aren't even aware is there, but there is a point object snap. Again, if you do a lot of work with Carlson point coordinates, it's a beautiful little automatic snapping tool that a lot of people are aware is there as well. Let's see here. Yeah, this one is, and I'm over on page 95, and this is under the points menu. And you can see down at the bottom, there's a part of this is, let me get this stabilized. Yeah, under point utilities, there is a command called search published control. Now, if you're not a surveyor, this may not have any bearing on anything that you do, but if you are and you're looking for NGS published control monuments that are out there, and a lot of times they're published in UTM projections in meters, and sometimes in NAD 27 instead of on the 83 datum or whatever. And this is becoming less and less of use because of our reliance on GPS and auto correction there. But what this would do would bring up a map interface and search around your area and let you find particular control points based on their order and stability and that kind of stuff, whether they're horizontal or vertical control. And then you see the ones that, oh, okay, I can use these, and I'll set those up. I'll set my GPS units up on those, and that will control my local thing, and I'll get everything on state plane. But what happens is that we would get those stations, and we'd have to, convert the coordinates into our local state plane wherever we're using them. But anyway, this little tool would allow us to pick up here in these tabs the ones that we want to use. And then we would just bring them right into our drawing, and it automatically will do the conversion, the reprojection, and bring all of that stuff in and put it on our, even if we're using a locally defined projection, it will do all that so that we can use them in coordinates so that they'll show up in the exact right place. All right, so that's a really sophisticated tool that so many people never knew was there, and it's been there for years. So it's worth your while perhaps to step through at least the book and see about some things. Point histories. And then once we're finished with that point menu, it just goes right on into this next section called Command Reference Civil Module Menus. Okay, now I won't talk about all of that, but it's the same structure, and it gives you the same type of step through, either expanding upon the help system or cutting it way down so that you're only looking at information that you might need to sort of keep the command at your beck and call, your recall, or at your fingertips, I guess is a better thing I'm looking for. Roadside ditch command, it's a sub menu, and things that you don't use a lot of. It's a really handy, and again, the red designation for things that are handy and useful that might be done a lot. But again, realizing it comes from my workflow, but my workflow is a lot more aligned to yours than say an all highway or an all excavator type company.
Right.
So, all right. So anyway, take a look at that. That's the structure. We go through the upfront part, the exercises down through that, putting it on together. That's our fundamental stuff. And then we hit into the civil specific. So yeah, that goes down through that. Then we start the civil specific, and then that command reference. Again, starts with the general, goes into the modular, and that's essentially it. It's all linked. It's there for your reference. Realize there may be some changes because this was written back in 2016. So it hasn't really had a chance to be updated fully yet, but we do use, when we teach with the new version. And it's really, they've just been embellishments on what's already there. So the process is underway, by the way, to get these brought up here this season, because we just got hired to do a sort of a continuing training program for a very large surveying company up in Maine, where they're going to put their new hires through 4 days of training and then 2 days of testing. And it's designed to let them know who they want to keep. It's also designed to let the students know whether they really want to get into doing this kind of work. They said, turnover has just been drastic for them, and they're needing some tools that are going to help them identify those who are going to be a better fit, and vice versa. It lets the students know as well. So anyway, so that's all underway, but for now, realize that you may look at this, it may not necessarily be up to date, in which case refer to the help system, and I'll show you some other resources you've got for things like that as well. The biggest resource you're going to have on a lot of that stuff is, let's see, I'll go to about your instruction. It's right here. You can get in touch with me anytime at all. That's part of what you get when you purchase training from MSoft, is you have access to me for tech support, either by email. If you have one of my emails, which you've gotten because of the class, then you have my phone number as well as part of that signature. Feel free in any way, shape, or form to get in touch. There's, I've got a client up in Canada, up in Windsor, Ontario, that, she's basically somebody they brought in and are starting to train to be a civil design tech. Well, she doesn't even know things like, what's a horizontal alignment, what's a profile. She's not familiar with these concepts. And so I do a lot of that kind of stuff. I'm almost like, engineering technology 101 professor for her. And, we do it until it gets to a point where, okay, well, what you're looking for really needs to be like 3 or 4 days worth of concentrated training, at which point they decide whether or not they want to, hire me back on a custom basis, or whether she goes and looks for some other resource, whether community college kind of thing or whatever. But anything that's like, anything up to a couple of hours, 2 or 3 hours that I can get in and get some examples and work with through you. That's always available at any time. It doesn't run out. If there's ever anything that I've also had people that have gotten really tight with schedules, and like there's a client up in Buffalo where he just flat out hired me to help him design a pretty high-end carriage home subdivision that was right adjacent to the Buffalo Bills stadium property, and there was this little canyon that ran through it. So there were a lot of wetland, and not not so much wetland, but these little canyons, these creek banks. There were I don't know exactly what to call them. But anyway, things that they couldn't go near. They couldn't grade near the edges of certain things. So they had a lot of restrictions that they had to use. And then when they crossed those creeks, they couldn't just dump a bunch of fill and put a big culvert under. They had to come up with these, Williamsburg type log and steel bridges, very kind of posh design things. And so there were a lot of tweaking from your standard class, so he basically, wrote me into his billing structure. And I worked back and forth on this stuff. I went to Buffalo for a week, and then we did a lot of stuff. The rest of the stuff I did via emails and Zoom type things. Of course, that was before the days of Zoom. But so all of that stuff is available. Keep that in mind. Again, like I said, I am a practicing engineer, licensed in Pennsylvania. So if you need something licensed in Virginia, I don't have that, even though I am Virginia born and bred. I grew up down in the southwest corner, down below Roanoke and Blacksburg, in that little part tucked up under West Virginia, down past Bluefield. Little town called Tazewell. That's about as far down as I can get it whittled. And and then I also worked, you may or may not have been familiar with the company, but the company was originally called Outsource because they did a lot of outsource work, like I was talking about, for people, a lot of 3D modeling. And then that term really sort of fell out of favor because of all the outsourcing issues with India and all of that. But we changed the name of the company to reflect the ownership. It was called Harkin Radar. There was Harry Ward, that was the Har part. And there was Ken Crawford, me, that was the Ken part. And Rayco Lewis was the Ray part, and Daryl Brown was the Dar part. So, but we were the training arm for Carlson Software. We went all over the world, actually. And I spent a lot of time up in Western Canada, spent some time down in the Caribbean. Harry, of course, being the founder of the company, he worked some in Hawaii and places like that. That's funny how I got the snow-covered plains of Western Alberta and he got to go to Hawaii, but still, ranked half his privilege. But that company was in Front Royal, there near you.
Okay.
Now, so I'm sure that we probably had at some point in those years run into some folks from your company. I'm trying to think of who's another company. Are you in the Chantilly office?
Yes. Yeah. So I'm with Bob and Jeff, Bob Brown and Jeff Gilliland.
Okay.
Jeff is one of the founders of the company, and I think Bob was brought on after they founded, but they worked together back at Urban.
Urban Engineers.
Yeah.
Okay. Yeah. So I know them, but there's another company there in Chantilly, and I'm trying to think of the name of it. I think they go by 3 initials now, but they used to be people, said their names, but it was like, I can't even remember. Gosh.
Yeah, so when I first started, I was working with um, Burgess and Nyepel.
Oh, okay, maybe that's who I'm thinking about. Yeah, we've done a lot of training for them as well.
Yeah, I think they started off as BD&E, which was Bankston, DeBell, and Elkin.
Oh, I didn't know they were part of that. Yeah, when
Yeah,
back when I was a young engineer, now this was back in '86.
uh,
They were part of this big popular thing to do was have a peer review. And if you're a civil engineering firm, you would ask another firm to come in and do a peer review of your operation and to show everybody how on top of things you were. Well, Curtis Sumner, who was their head surveyor, a good friend of mine as well there, and I worked for Anderson Associates, which you may have run into them up there. They've had an office there in I want to say Warrenton. I'm not sure if that's where their office is or not. Maybe not. But anyway, um, it was in the Blacksburg office. But be that, it was Bankston, DeBell, Elkin, and Titus in those days, and they were part of that. And they came down and rated like 4 or 5 of our top department leads, one of whom was Kurt Sumner. Now he went on to become he was the director of the American Congress on Surveying and Mapping, nationwide. He's a pretty big time guy that everybody knows. But yeah, so that became Burgess and Nyepel. Huh? I didn't know that.
yeah, they got wrapped into then, and then back in 2016, I went over to, or beginning of beginning of 2017, I went to Panoni, which is
Oh, sure, yeah. Well, no, we had a Pittsburgh office there. There's a guy named John Scorpin that was the head of the Pittsburgh office here for Panoni. And
yeah,
he's actually a retired NFL football player, but who happened to have a degree, his undergraduate was civil engineering, but he played, he was a starter. I don't remember who, the Raiders, maybe, I don't remember, but
oh,
anyway, so we did a lot of work with them here as well.
yeah,
Um, I'm not sure, I haven't, and the pandemic and the shutdown, that's changed the landscape so much. I can't keep up with all the changes, but there was somebody else, and I can't remember if it was in Chantilly or if it was in Gainesville that we ran into. But do you happen to know a guy named Chuck Henniger, Charles Henniger?
the name doesn't ring a bell.
Yeah, he has done the last several years. He's really done a lot of forensic engineering, a lot of forensic testimony, in court and stuff. But we we were in a meeting with them up here, just outside of DC, and I've been in Pittsburgh for 15, 20 years at this point, and I'm working with the company out of Front Royal, and we're having this meeting, and this guy walks in we wanted to introduce you to our director of engineering. He does a lot of this, and it's Charles Henniger. And I went to high school with this guy, 30 years prior to this, down in the southwest corner of Virginia, a little podunk town. And of course, he was like this little skinny, knobby-kneed dude with curly hair. He was the only white guy I ever saw with an afro, and it was better than all the black guys trying to grow afros in those days. And he had it figured out. But I said, "Oh my gosh, it's little Chucky Henniger," and everybody looked at me aghast, like, "Oh, you can't talk like that to the director of engineering." And I said, "Are you kidding me? Of course I can, since I used to kick his tail in basketball." So, but yeah, it was odd, and we got to find out he wound up catching. I guess he ran into somebody, much like when BDAT was down doing the peer review. Somebody spotted him. He had sort of worked his way through the community college end of engineering,
Yeah,
and got transferred up and got his bachelor's, I think, from Virginia Tech. That's where I got mine from, but I'm not sure. He may have had a different route. But anyway, somebody spotted him and brought him north and gave him a chance, and he just sort of grew with it over the years and was running. So I was kind of impressed with that. But anyway, to get back to all of where we left that tangential, anything at all like that, that if you guys ever need help, reach out to us and we can help. We can find other people that can help if you need it. So that's all part of the package. That's what you've got access to. All right. So with that, let's see, it being 10:30, it's about time for a mid-morning break. Let's take 10 minutes or 12. We'll come back at say 20 till, and we'll get into this other stuff, and I'll go ahead, like I said, and switch over to the AutoCAD version, and we'll start stepping through the actual content. Okay. All right. So what I'll do is I'll come back. I'm going to stop this. Let me stop the sharing. And okay, so
a little bit more often.
Okay.
Now, I have tried to play around with them very, very
just some
capacity.
all right.
Like, I was generating a surface.
Okay.
Noticing some, like basically we had 2D 2D polylines, let's say, with elevations associated with them.
Yeah, like contour lines maybe.
Right. And trying to generate an actual surface from an existing topography. And
Okay.
I don't know how best to describe this, so I'm just going to do the best I can. If say two contour, if you have like a saddle type situation where two contours are approaching each other at a sort of ridge line, but they don't really touch. And when the surface is generated, not knowing the proper settings to have enabled or the certain,
you get the old stair step profile down that ditch or across the ridge.
Or the contours jump across from one polyline to the other when really they need to just wrap around. And I know in civil, at least in Civil 3D, you can go into the tin surface and add points at elevations to kind of
to
do what you do. And so I tried to do something similar in Carlson before, just not very much.
Okay.
Not the only exposure to points that I have. So
all right. Well, we'll take a look at the points concept. I want you to understand, like, things like you know what an AutoCAD block is and all, what attributes to a block and all that is, right? Jacob?
Hello?
Yeah, I'm saying, like, what an AutoCAD block is, and a block that has an attribute and things like that, right?
Yes.
Okay, so what I want to do is we're going to start looking at the points. I want to explain to you what a Carlson point is actually composed of and how you can use those, or how you could ignore them if you so choose. Because in Carlson, you're certainly free to use just a standard AutoCAD point entity. It doesn't have to be a Carlson coordinate point with a number and all of that. It could be simply an XYZ location in your CAD file. That's certainly there. But the key concept to remember in all of these things that, and we'll touch on this when we look at the terrain modeling, we really talk about that, the ridge line, ditch line concept, how we can get around those kind of things. And you're going to see those effects here with these exercises. I'm not going to get into say using point groups. I think you can refer back to that in your exercise if you ever get into where you can take advantage of that. But that's really more for people that have, you know, thousands of points in their coordinate files and they want to group them into certain categories and just refer to them by the group name, like all my control points or my center line of road points, or, you know, that kind of stuff.
Yeah.
And it's pretty straightforward. I'll leave that part alone. But let's talk about, well, we're going to start even before that. Let's talk about some settings.
Okay.
And these are some of the upfront kind of global settings that we're going to talk about. So this is on page 10 of the manual where we start talking about them. And most of those are controlled at the global level on the settings menu, this thing called Carlson configure. So what I'd like you to do is go ahead and load up Carlson and just start a new drawing. And so when that comes up, it will load whatever whatever template you may have set to use. What? Product license only. Well, I'm not understanding this exactly. Let me see that, and that is probably from take a look at that, see if it's a Carlson or an AutoCAD thing. This should be. It says it's registered.
Oh.
Not figuring this out.
Seems like everyone's having technical issues today. We're currently having issues with the server on our end of things. We're using a cloud server for storing all our files, and it has not been accessible all morning.
Wow, I wonder if something's going on, because now I was able to see, I log into my account.
Yeah.
Everything's there. Well, I may have to switch back to IntelliCAD if I can't figure this out, because it's, yeah, see, I was running this stuff yesterday with, I also I'm doing all this on a Macintosh, and I used the Mac version of AutoCAD as well, and that license also allows that. See, this is coming from AutoCAD. I'm going to have to, I guess I'll have to switch.
Shouldn't be a problem.
Yeah, it shouldn't be. You should have the same functionality. I'll try to figure that out tonight. I'm not going to waste any class time doing that. So let me, wait a minute. Now this is, seems to be working here. See, it's this managed license. I'm wondering if there's something, see, this application not being available.
Something's up, might be up on Autodesk's end then.
Yeah, that's what I'm guessing, because it's not able to check the heartbeat and check into the license. But it has been renewed. I don't know. Like I said, I renewed that back in February.
Hmm.
All right, so let me get out of this stuff and I'll go back to the Carlson side. Sorry about that. The IntelliCAD version. All right, I'll do a new drawing. Let's see, civil. Does it really matter at this point which one I use? All right, so I'm going to start this up. Now this wizard, do you use this when you start yours?
No.
Okay, so probably at some point you check this skip startup wizard next time, and that's fine. But one of the things that I like about this is that it forces you to know where your drawings are going to go. So I'm going to set this to a new location, and I'm in my Carlson projects folder as my starting location. So I'm going to come down here and find my April 7th civil class. I'll set that there as my location, and I'm just going to call this one class example 101.
Okay.
And I'll leave it at a 50 scale. Now, some of these things to understand right here, and this also applies to where you're asked for these things in dialog boxes. There's a key term here called symbol plot size or text plot size. Now, what that means, if you're comfortable with and understand the annotation scaling with AutoCAD, that sort of correlates to that concept.
Yeah.
And what you're setting up here in your scale is your anticipated scale for your final output plotting. And you can change this at any time. But the way Carlson works now is you set this scale here, much like in Civil 3D under the ambient settings where you set that up. And then when you fill out dialog boxes, you're going to answer this question as plot size, or sometimes you'll see scalar instead of plot. And that means if you are producing this for 1 inch equals 50 feet, this is going to be the size in plotted inches, not the ground distance. And so that sets over here these values that it hands off to AutoCAD when it needs to hand off size information. It does it in ground units. So if I change this to say a 30 scale, these are going to stay the same, but you see how these change over here.
Yep.
So that sort of keeps you from having to figure out all the height units and stuff. The dialog boxes are going to ask you most often. There's a couple of places where it doesn't, but almost always it's going to be asking for those plotted inches in terms of height. Okay.
Yep.
And then that means that sets it for anything that you create with these settings in place as they are now, that's the size they're going to use. So even if you don't use annotation scaling, when you create those, it's going to create them based on that size. Now that creates the one thing, it's not annotation unless you decide to use annotation scaling. And if you do, then your text styles that you use need to be set to annotative, and you can continue to use those just fine. You don't have to worry about them. If you change scales, then it will resize those for you with your annotation. Okay, so it's there either way if you want to use it or not.
And this is going to apply just to this drawing, correct?
That is correct. Now, it may keep it to whatever you've used last, or I think there's a place you can set in your setups that you're going to come in with a default size. But if you ever, if you don't use this to start with, I'll show you where you can change that as well up in the menus. So we'll leave that there. If you fill out things like project name, job number, and location, you'll see those as little header lines and reports that you generate, things like that. But so I'm going to go next, and now here's where a lot of people, get confused with this as well. It comes up because, and this is more legacy than anything else, it wants to associate a coordinate file with this work, and it suggests one of the same name, puts it in the same location as the drawing file. Now, that doesn't have to always be that name. You can change that to an existing one somewhere else. If you've got one, called big project coordinate list, whatever, you can hit the set button and go out and find it. We're just going to take it as a new coordinate file. And one thing you have to be careful of is if you choose this and go out here and find, say, another coordinate file that you're going to use, and then when you come back into there, because it says new, it's going to try to overwrite that. So you would need to switch that to here before you change set. But we'll leave it new, keep it empty. And the wizard here also allows you to go ahead and import points from other files or a data collector or none, which is what we can do, because you can always do that manually with a different command. And then we'll just say next, and off it goes, and it puts all that in the right folder and everything else where it's going to be stored. Now, do you use the ribbon interface?
Yes, somewhat. I use a mix of ribbon and command and keyboard commands.
Okay, so like now mine is set up right now where I use all of these toolbars, and I've got my ribbons turned off, and I can just right click up here in the blank spot and say switch to ribbon if I want, and that brings up these ribbons. Okay, and they're sort of organized based on functionality, based on those panel settings right here. Now I also still have the menus on.
Yep.
I find when I do that stuff that when they first switched to that ribbon interface, it wasn't real clear how they organize things. So I'm going to turn that off. I'll leave that, up to you. You can find those as you're going through those as well. And we're going to work, I'm going to show you where all these commands are on the menus, but then as we learn them, as they also apply to toolbars that I have out, I'll show you where those things are as well. If you ever see me grab a command and you don't know where to do it, stop me right then so we can, don't get behind trying to find the command if I go through something too quickly.
Okay.
All right. And let me see what else was I going to say there. Okay. Back to these settings. So if you don't use a wizard when you start things up, and if you ever need to change that scale, just go to your drawing setup on the settings.
Yep.
And that brings up a place to put it here. And there's also some things here. Now, one thing I will say about this line type scaler, this is, notice that it sets a global LT scale to 50.
Right.
Because that's a scale. Now, I don't work with line type scaling that way. This was done to use the Carlson line types that they built long before AutoCAD really got a little better with line styles. And so they use that to be able to redeploy that to show up at the proper scale. So what happens with the line styles that I assign to layers, for instance, I use strictly AutoCAD line styles or line types. And so I need to come in here and set that back to 1 so that they show up correctly.
And that's how I set my stuff up as well.
Okay.
I'm not used to doing it the way, with the LT scale set to whatever the actual horizontal scale of the drawing is.
Right, exactly. Because, the way I do it, I use like one master drawing and I may cut 12 sheets out of that at different scales. So yeah, so that's so using that, and then there's an MSLT scale and a PSLT scale that you need to turn those on as well. So
I've encountered both of those things since I started working here, because drawings get set up by different people, different ways, and people leave, people come, and Yeah, so I've learned that I have to go back and reset this sometimes. Now,
Right.
while we're in this menu, I just wanted to ask, what is the symbol plot size? What does that affect?
That if you do points, if you use Carlson points and you choose a symbol to plot with that point,
Okay, like an
that,
X or something or a square?
yeah, triangle, circle, plus mark, and X, anything like that, that sets the plotted inch size of that symbol. Now, symbols can also be done, I'll go ahead and cancel this, under, you can draw symbols and you can insert symbols without them being associated with a point. And that also affects that. And you can see when that comes up, you choose the symbol
Yep.
and so now here's this symbol scale that's going to work.
That's 0.150 scale. Right.
Yeah, I'm not sure exactly. Now, if you use annotated symbols, if you have annotated blocks that you can use for symbols, then you would set that appropriately. And I'm not sure, putting it to 1 or putting it to your desired scale. I think if you put it to 1 and if they're annotative, then when you turn on your annotative scaling, that takes care of it. But most of the Carlson symbols that you select out of this pull down list of symbols, these are all drawn. And if you want to use your own and even annotative, create your blocks at unit size so that the height of it is 1 in your block editor. Okay. Now, so when you're choosing those, don't miss out on this list of categories because there are all kinds of different symbols.
I see.
Beyond just those one. And you can make your own custom, different symbols that you're using there.
So how would you, like, let's say we need our drop inlets to look a very specific way, besides what may be default built into Carlson. How do you load those into this? You just
Okay.
search.
Yeah. So what you're going to do is, first of all, let me show you another button right here called Carlson Community.
Okay.
You do that, that's an online type of thing here, and you can choose, let's see, file list, the icons. Let me cancel that for a minute. So you've got all of these different things, and see, they were uploaded and shared by other people out in the world. Okay. Accident head symbol, for instance, if I use that, then you can download those and include them. And you've got all these different categories: crime scene investigation, mining, different objects, vehicles.
Okay.
Okay, different reasons like Mass DOT, Russia and CIS, that would be something good to use, and survey symbols. So, you've got all of these different things that you have available as well. But now to answer your question, I'm going to go ahead and exit this now. The way you would control that is under settings, symbol library. Okay. And I got a bunch of failed to load symbol, blah, blah, blah in the mass dot. So I don't have it linked. So what you do is you have these different categories over here where you can add a category, this button, and that adds these different categories. I've got this one called City of Windsor, manhole sewer, WUC, whatever that stood for. And you see it's not linked to that anymore. The category is still there. I just have changed machines since. But what you would do is you get on a particular category. Let's say we get on inlets and manholes, for instance. And you see all these, and let's say you had a particular, see if I can find that might be a drop inlet, a graded, a grate in the gutter and an open top. But right now, this is just a 2D symbol. Now you can actually have a 3D symbol and plot with those as well, so that you've got the entire structure drawn as 3D. So what you would do is you would come down here then, and you're going to import symbols, or you could create a symbol. You can import an entire library of different symbols. And when you, let's say, import a symbol, it takes you out here, you just go out here and find Yeah, those are poor examples. Let me see if I can. All right, we'll call that a plant 04. Might say open to that. Well, then now I've got plant 04 is going to show up, and I can bring it up or down. Let's put it in my custom here. And then we'll save that and exit. And so then if I go to draw symbols, insert a symbol, and I select, and I'm going to choose that out of my custom. Right there's that shrub. Okay. And then now I've got that as a scale of 5. Let's see what happens when I place it here. Let me get an idea of what this size is. I just go from say here to here. That's 5.
Okay.
So that comes in at, now remember my symbol size was set to a 10th. So that should have been 5. So that took care of bringing that in at the right size.
Got it.
Now, if I do that, let me put this down to 1 and see if that cuts it down or if it ignores it, because no, that cuts it down. Yeah.
Okay.
So that, yeah. So apparently that 5 is probably, and I wonder if I set this to 30, and because I say 0.1, I wonder if it changes the default is my question here to 3. Nope, it leaves it what it was. So yeah, that's something you would probably need to
so it remembers whatever the last value you input, and it's not necessarily defaulting based on the default drawing settings.
That is correct. Now there's a setting. Let me see. There is a setting some where it's not. There it is. Here we go.
Okay.
I think it's in here where it pulls out when it says use configuration. I think it's going to read your last, it will save those. It's like save command settings in Civil 3D.
Yeah.
So I think that's where that comes into play. So, all right, now, some of the settings that we want to be aware of is, I'm going to come back to these general settings here and sort of talk about them last, but let's look at a couple of things that would be helpful. Is if you happen, do you have the survey module also installed?
Yes.
Okay, so look at the survey settings, and it used to be by default, this number right here was set to compact, or this pull down for CG survey menu. And if it is, I'll go ahead and show you what that effect is. You get this CG survey menu.
Okay.
There's file, traverse, Kogo, draw, all of these. This is the entire CG survey program written as an included sort of subsystem to Carlson. And that was the old Cowherd and Goodman survey program that a lot of surveyors used to use before switching to Carlson. And so that's there, but very, very few people still use that. So if you don't want to see that menu, if you're not ever using any of those things, just go to the survey settings and pull that down and choose none.
Okay.
All right. And then let's talk about the project and data folders. If you choose that, what is yours set to right now?
Right now, mine is set to project folder.
Okay, so are you comfortable and understand how that is done and what happens when that's done?
Um, never really paid attention to it.
Okay,
Again, since I'm pretty much going to be the first person who is going to have a decent understanding of all of these things.
alrighty.
So as far as I know, we do not set up like in Windows File Explorer when we're setting up a new project. I don't know how many people are actually using this to set the project folder up at the beginning of a project.
Right, okay. So what this allows you to do is, and this was done to mimic the way Land Desktop worked, but if you choose the project folder mechanism, first of all, there's three different options. One's a fixed folder where you set a hard-coded folder, and that's where everything goes. Doesn't matter what project you're on or whatever else. And that used to be the only way this software worked back in like 83, 84. And it was a folder called SCAD for ServCAD. That was the main name of the program. But now the default is drawing folder. And what that means is that all of your data files that it's asking you to load or to save and all that, they are going to, by default, look in the same folder where your drawing file exists. Okay. And if you wanted to, just to keep things clean without messing up, all of the things on your server locations, you could switch it to that for the purposes of the class. Just make sure you switch back to the project folder later, or you can leave it at project folder. It's not going to hurt anything. And again, all that does is set the default location of where things are looked for. You can pull down and change away from those at any point in any of the dialogues. So that doesn't lock you into something. It just keeps you from having to navigate so many folders all the time. So what project folder does is you set up a list of subfolders. And if I choose this one, I have some already set up in my template like so. And you don't, it doesn't have to be any set order. Now, Land Desktop was a particular set order. You couldn't control that, but that was where everything went. So this lets you actually create new folders and subfolders. And you can see I've got things like alignments and profiles are going to go here. Deed information is going to go there. Points, surfaces. I've got one for my drawing files. I've got contract information. I've got deliverables, point clouds, PDFs, program settings. Well, that one can't rename that one, but so all of these are different subfolders that I can choose, and I can have as few or as many as I want. Okay.
So you're basically creating you're just creating the structure of the project itself.
Exactly. This would be what you were referring to a minute ago as somebody going out into Windows File Explorer and setting all this up.
Right.
The beauty of this is you don't have to go do that in Windows. Carlson will do it for you. Okay. And this project up here, it's not a folder called project. That's just whatever the project name is. It goes out and either looks for a folder of that name or it creates it if it doesn't find it. And then it looks at the structure. Now, let's say you have one already done. Somebody's set up and they've got like 3 folders in it. And, but then but you want to have more than 3. So what it does is it goes and it looks at that. And if you've got a folder in there already called data, it doesn't overwrite that data folder. It just looks at what you've got there. And if it has any subfolders in it, it leaves them alone, but it adds these to it. Okay, so it doesn't destroy anything you've got. It just fleshes it out into this particular structure.
Okay, so just to make sure I understood, we've already established a project and set up certain folders through Windows File Explorer, and now we're deciding to switch over to setting things up through the project setup. And if there happens to be a folder with the same name as what we're setting up here, It's just going to supplement that. It's not going to overwrite anything.
That is correct. So if you have one called points, for instance, and you have a folder called data, and it has a subfolder called points, and it doesn't have anything else. Well, it leaves data alone, leaves points alone, but it adds these others into it. Okay. And of course, if you didn't have anything, it would create everything it doesn't find that's out of this list. So you could decide that you want to just do everything from here.
Yeah.
And once you have that structure set and everything there, you can, you can share this whole thing with everybody in the company, but just put it on you come to this list and you do this save as, and you put it on a location that everybody can get to, and then they can load with this button. Okay.
Similar to like settings for like the sewer network or the road network, like those like label settings or how things are displayed through RoadNet or through the storm network.
Yeah, well, those particular settings on those specific commands are different. They're stored deeper down.
Right.
All this is setting up the folders. Okay. This sets up the folder structure. Now, how you want, like if you want to do your profiles as a 4:1 vertical exaggeration versus a 10:1 vertical exaggeration, you want your grid lines every 10 feet or every 20 feet. All of those things are stored in the dialogues that control those commands.
Right.
So you can do that at any level, save and load those commands, and you can do it, based on clients. If you're doing a lot of work for VDOT, then you can have a VDOT structure set up. And you can also have this set up, you can save one as a VDOT location or one as, Loudoun County or whatever you happen to be working for.
Okay.
So, and again, all of that stuff is shared. And the whole point of being able to share that is to get everybody on the same page, of course. All right. So, and again, all this is doing is creating folders. And then this other button, the data type subfolders, is where you set a particular type of file. And again, you got your categories and such over here. Notice my CRD file, and I look over here and I see that's a coordinate file, and it's going to go in this folder called whatever the project is, data points. That's where it's going to start looking for those particular things. Okay. My deed correlation files, I'm going to store that in my project data deed info. Lot reports is going to go just in project survey and points. Okay, so and notice these others that don't have any assigned to it, then that's fine. You don't have to assign these different things. But there's another nice little tool about this. Let's say you were using this drawing, follow the drawing. Let's say that's what you were using all the time. And if you ever wondered, you run across a file extension, you're not sure what it is. If you switch to this in this command temporarily and hit this data type subfolder, and if I'm in all categories and I look at this dialog, I can see that this goes all the way down to, there's 236 different file types, at least in this version. And it tells you what that is. So if I see that I've got a ZON file, what does that mean? Well, that's an earthwork zone definition. A TMG is pit scheduler timing grids, and that has to do with the mining software. So, that shows you what all of the files are. So if nothing else, that's a good way of seeing what files are what.
So this just basically instructs Carlson on where the default save location for these different file types is?
That is correct. So in fact, let's see if I were to choose that, I've got one, it would create that. I'll go ahead and do this for a minute. Let's leave it like this, and I'll leave it as project folders. And I'm going to say, okay. And I'm going to say exit, and I'm going to, let me just draw a located point here. And I'll just put it on the screen. I'll put it there. And let me change that again. I've got a default turned off here. I want to make sure I use descriptions and elevations. Locate on the real Z, use point numbers. I don't know why I didn't do that. All right, so I'm gonna put one here. Go back to my locate point. Screen pick, and I'm gonna put one right here. It wants to know an elevation and description and point number. Well, we'll call it 2 for now. So now I've got this one, and it came in with these defaults and this particular style, which is a text style that's pre-built called PTXT. And so now I've got these points, or at least that one. Let me do that again. I'm going to turn off to use the formatter. All right, so there's my point number 2 that I just built. The last one I used, I didn't have my default set up, so it didn't store it as a point. So now I've got a coordinate file there. So if I go up and want to say, set my coordinate file, see up here, it is in my current location, but here's the default where it's going to start looking. And I see in here, I've got this one. Let me see if I put that in the right place. Still looking. There, did I not? Project folder, there's a setup, it's under data points. Data points, okay, that's fine. All right, so if I want to say set coordinate file, new. Yeah, this is supposed to switch to that, and I'm not sure why it's not doing that. That may be maybe something that got broken in the last update, or maybe I hadn't set my project name yet. Let me see. So reassign data folders. No, let's see. The current project folder is civil class. That's correct. See, and there it built all of these things here.
Yeah.
Um,
Current data folder.
So here's my current project folder. That's fine. Let me clear the data history file selection. Let me try this. It's not going to check. If I set this project file, no. For settings, no. Current project. Don't have a project set. Let me see if I. With data, drawing files, and other. I'll just call this one class and see what happens. I had a drawing, let me see. It should be okay. Now, if I draw locate points and if I choose to set, okay, there it's looking for it in the right spot. If I say switch to civil, and if I want to centerline editor and I go to open, yeah, see that's, well, I may not have that one assigned yet. Let me see. Yeah, it's just in projects. So if I were to go here and look under data alignments and profiles, and then if I want to run this, I'm going to choose a new, yeah, see how it switches up here to whatever I have assigned there. And all that's doing is putting the starting location. I can at any time choose any of my recent ones or go to browse, and that just puts you out in the Windows browser.
And it puts you, I'm guessing it puts you close to where that starting location is.
Well, yeah, the starting location is this Carlson projects. That's where I told it I'm going to start.
Right.
And that is done with under here, the startup data folder. So that's where I'm going to start looking. So I would put my server drive and heading that where all my projects are stored as my starting,
Right.
my startup folder. But then whenever I choose those types, if that type is assigned under this data type, then it would find, would find those things like here, DWG files are going to be in project, and whatever the project is. Now, once you create it, you'll assign that a name and it names it that folder. And that's where it goes down. So right now my project is my class location, or the, let's see if I do a new. All right, so see right there, there's now my project. And if I give it a name, I'm just going to call it, test, and say, okay. And I'll just exit that. Now, if I go to, let's say if I close that off and I open this up and I want to open a drawing, and that's going to be in my drawing files there. See, that's where it went. By that last time I went to save it, it was pointing to that location. So again, all that's doing is setting up these default locations. You can navigate away from them anytime you want, but it starts you in that startup location. All right. So anyway, I don't want to dwell too long on this particular thing. I just want you to understand that structure, and I think you do pretty well. Now, just to keep everything structured here, I'm going to go ahead and switch mine back to my drawing folder. And let that up. Now I'm going to also show you, if you get something, if you're using points and you like to use your descriptions maybe, and you're going to freeze off elevations and point numbers. When you do your points defaults, there's this picture right here is called this attribute layout. And there's 10 different ones. There's one would be, or 0 would be the same thing, point number at the top centered, elevation to the right, and description at the bottom centered, And this is just a little preview. And like, I like to use this one where the point is actually over here to the middle of the elevation and everything is stacked. So if I do that and then do a new point, and I go right here for number 3, and I'm going to call that at 100, and I'll give that one a new point. And point number 3, there it is. Okay, so it's a little different layout.
Okay.
Of course, these can all be, manipulated. You can move those around.
Right.
To,
On the starting value of how it's going to look.
yeah. So, and we're not going to dive too deep into all that, but if you do happen to use these points and use descriptions for labels, and you don't like that text style, you can, in your style command, or here's the IntelliCAD thing with the layer things, I can choose all these different categories. Text styles is one. Here's one called p-text, and I can change that to be let's see, what was
Arial, or
yeah, anything that you want, and then once that's done, you've set that, so it just changes that for you. Okay. And you can set that up in your drawing templates so that they're predefined, and that's a text style called PTXT. Anyway, that's sort of behind the scenes, under the hood kind of stuff. And now I've got these points. I'm going to erase them. Now they're gone from my drawing, but they're still in, of course, my coordinate file. And there they are, 0.2 and 3. All right.
So, if I guess the way we're looking at this right now, that coordinate file is persistent in the drawing.
It is, and it stays here even when you save and reload it later in another session. You open it back up and it will associate it with it, and it does that with this particular close that off a minute and get to just this one. And it does that with this Carlson projects. Here's my civil class. There's a file in here. It's an INI file called a drawing INI file, and it's the old Windows INI type file, but it's the same as the file name, which was class example 1 INI. And if I look at this file, it's empty, of course, probably because I haven't saved the file. Here, let me save this. And then let's go back to that, or did it go here? Nope, it should be here.
There's a backup.
Yeah, it's the one I'm looking for is this one. There it is. I hadn't saved the file, but you see what it does is it writes this in there. That tells me my project path. This tells me my coordinate file, and that's the last one I've had associated. When I do another one, it would put another entry. And it's either the last one in or the first one. And it either writes it to the top or writes it to the bottom. I forget which way it goes. But this is what holds all of those different things for you. Here's my current symbol cell that I used. Field to finish name, a GIS name, anything that is set, it stores it in this file. Okay. So that's another good file to know about, in case you're ever sharing this information with somebody else that uses it and say, hey, I don't have that file. Did you not include it? You can go back and look and see which one it is you need to associate it with. Now, in that regard, this point file is the one that is currently set, and you can see it up here at the top. It says, Carlson Civil 2022 CRD file, class example 1. And then it says class example 1.dwg. So it shows you the current drawing and it shows you the current coordinate file.
Yeah.
And sometimes that says none, because if you just open up a file,
It
there's
doesn't
not,
have to be associated.
yeah, there's not necessarily one associated with it. But then let's say if I switch to a different coordinate file and I want to use this exercise 1 coordinates, see how this has changed up here now to exercise 1 coordinates, yet the drawing is still class example 1. If I say that and go back to let's go down here is the configuration file. Class example 1. So now you see that has changed what coordinate file is associated with it.
So so I wouldn't have to set this each time I open this file. When I save this file, close it, and then open it up again, it's going to automatically pull that coordinate.
Yeah, so if I close this file here, it's closed off now. Now I'm going to go back and reopen it. And you see the coordinate file up the top, exercise 1 coordinates.
Yeah.
So there it's there. Okay. So back to yeah, I've got nothing drawn in there. Okay, so back to our settings as to what we're looking at here with these project data folders. Again, what you're setting here is just some default locations as to where they go.
Yeah.
And 1 second, I've got a call that I had to turn off. All right, so anyway, I'll let you figure that out. And what's good about this, especially in larger firms, is that somebody else can come in and open your drawing and all of this structure is still intact. And so they can make sure they're using the current versions and the right versions and stuff.
Right settings.
Yeah, as to where things go. Now, we want to look at a couple of other quick settings here. Under surface settings, this has to do more with grid modeling than triangulation modeling. So we're not going to be doing a lot of that. The mining software uses gridding really heavily because it's better suited for that type with multiple strata layers.
Right.
So that is, how far away it looks for adjacent grid points, how many samples to look for, what size or number of grids that you want across the project dimensions, et cetera, et cetera. And then you get down into here, these settings back here, to simplify differences 10 to reduce the size. And a difference 10 is basically a 10 surface of the amount of cut and fill when you're doing a difference between 2 surfaces. And that's just a way to reduce size. I'm going to actually uncheck that. It doesn't really matter. But I don't want to throw away any data in the simplification. Now, when you track your TIN history, if that's on, that allows you to roll back edits to the TIN file that you may have made, that you and it keeps or reapply them later on if you want to go back and redo some edits you made to the TIN file. A lot of people work that way. I'm not a big proponent of editing the TIN directly. Sometimes you have to, sometimes, it's quicker to do it that way. I like to actually fix the data that built the TIN and recreate the TIN so that problem goes away.
So like your 3D polylines or your break lines or your contours, you're adjusting those directly instead of, dropping in a new point on the
Exactly correct. And like if I'm putting in a point to control something in my TIN edit, that's the only place that point lives. Now it recreates the 10 and it incorporates that point, but it doesn't put the point in the drawing. So I'm more a proponent of, well, put the point in the drawing. That's part of what you're working with. And that way, if you ever have to rebuild that structure, it's part of the data set now.
Like, let's say, for example, you've generated a tin surface, and on one of your 3D polyline or break lines, you forgot to set a elevation on a node. And so now there's a hole in your surface.
Yep.
Instead of, fixing it in the tin, you would just go back to that break line, set the elevation for that point to what it's supposed to be.
Exactly right. That's my approach. Now, it doesn't mean you can't do it in the 10 edits. You certainly can. But if you want to be able to do it, you know how Civil 3D keeps the 10 edit history?
Yeah.
That's exactly what this is doing. But you have to turn it on. It has to be on in this surface setting. So you have to make sure that you track the 10 history and that you track surface data changes.
So what exactly, what exactly would you be looking at with tracking tin history?
Well, sometimes you build a 10 and you look at, let's say you build it just say from straight contour lines. And then you decide that, well, I'm going to put a break line in connecting all the nose locations of all of the contours up a valley.
Yeah.
So when you add that break line into that 10, if you're doing that in the 10 edit, that's the only place it lives. If you go back out to your drawing, it doesn't create it in the drawing. And then later on, you do something else that's going to modify that surface and you rebuild it. It's not going to apply that unless you go back into that 10 history and select it and say, reapply that edit that you made previously. Okay. And you can turn those on and off, just like in Civil 3D, those particular edits into the 10 file itself.
Okay.
Okay. So again, I don't work that way in the sense that I like to, because I really get into visualizing all this stuff in the 3D viewers and understanding exactly what's going to happen in my surfaces. And I can look at that and I can tell where I might need to put in a particular
a break line or a point or whatever.
Exactly. Yeah. And now I'll give you a real quick example of that if I can find it. Let me take a look here. I've got something. Let me see if I can locate it. Let me see. Let me try it this way. See if this is the one. Yeah, this is the one I want to talk about here. So this was an article I wrote for American Surveyor magazine, for instance. And it talks about a very common misconception with terrain modeling. Is I had this condition. I've got a building edge and I've got a 10-foot sidewalk with a negative 2.08% cross slope. Now I use that number because that's a 1/4 inch per foot drop to get my drainage. Roadways are typically 2%, not 2.08. But anyway,
Yep.
I just want to drain my building, which is at a particular elevation. I come down that 2.08% and I've got the edge of this parking lot, and that sets that at 100.5, and this is 100.5. So whatever the building is 2.08% higher, and it sets this edge. It's also level.
Yep.
But I'm going to go down here 3% and down this side 1%. So this corner is lower than this corner, and this corner is lower than that. All right. So if you just simply model the building edge, the edge of the parking lot, the edge of this parking lot, it's going to generate some contours like this at first, because I've got a point here, a point here, a point here, a point here, and there's a triangle. There's only two triangles in this.
There's no line in between the 97, 98 and 10, the opposite corner.
Correct. Yeah.
Maybe,
well,
maybe
yeah. I mean, even if I had drawn the break line from this corner down to this corner,
I guess that's still only two triangles. Yeah.
it still would have formed like this, and it would have gone right across that crease. And these two triangles would be, you would see that come down. There would be a hard crease in the middle here. But my intent was to not make the hard crease. I wanted to make this a smooth transition.
Right.
So a lot of people think, well, all I got to do is turn on contour smoothing, and they'll do that, and they'll show these contours. They go, oh, look at there, it's nice and smooth. I'll go with that. The problem is contour smoothing, all that controls is how it draws the contours.
Right.
The surface underneath this is still two triangles with a crease down the middle. So I'm going to need to densify that structure. And if I do that by putting a bunch of lines across, like these lines across here, but I just go edge to edge and nothing in between, I'm going to wind up with these kind of contours. You've seen those, I'm sure, the little jaggies. And a lot of people will go into their 10 edit and they'll swap triangle edges to try to smooth that out.
Yeah.
Well, okay, that's one of the 10 edits you want to try to keep a history of if you need to reapply it. But again, to me, I know what's caused this are these long edges, and it can only form triangles from the points within those lines. I've only got endpoints on these horizontal looking lines.
Yeah.
So to be able to get that more smoothly, I do that. I put the lines there, and then I densify the points along those lines by dropping these points. And now the triangles are going to form between all of these points. And there now is the resulting contour lines drawn with contour smoothing off. But that's really what I intended that surface to be like. It's a nice, smoothly sloping parking lot surface.
Because when you're thinking about it, you know, in your head, you're like, okay, well, this parking lot is sloping in one direction. You know, one end of it may be a little bit steeper, one end of it's a little bit less steep.
Yep.
You would expect the contours to just go in a straight line from one side to the other, kind of like this picture is showing.
Yeah, this is my intent, and that's what was in my mind to start with. Yeah. But if we go all the way back up to, you know, this first condition,
right?
I set this line and I say, okay, good, I'll just fill the surface, but the surface only has these 4 points to work with.
Yeah.
So
it doesn't know what you're trying to accomplish on its own. You have to kind of help it along.
Yeah, that's right. So I need basically to add a bunch of points in here. Now, I could have done that with my edits to my 10 directly. I can fix the jiggy jaggies with some edge swapping, but that only does every 4 triangles, and then it starts it over again.
So then instead of the, I guess, if to make sure I understand this sort of process correctly, instead of doing the contour smoothing, you have to densify both the edges and the points, or is it one?
Yeah. Well, so what I did was I drew a line from this corner to this corner,
okay,
and then I arrayed it.
I see.
You know, 10 times or 50, however many to get to this corner.
So you have to manually do something in order to get it to generate.
Right. So I did the one, I arrayed it across, and then I draped it onto these edges so that the endpoints hit the endpoints. And then they still didn't have the points in between. And so I densified those lines to say go every 10 feet and drop a point.
Oh,
And,
okay, okay.
and that makes it available as a corner of a triangle. Whereas before I still only had either the 4 points on the edges or the 1, 2, 3, 4, however many up each edge, and still nothing in between.
Yeah.
But then this is what results from that. Now, I'll give you an example of why, so many people don't understand this concept. I've got a really good friend here in Pittsburgh. His name is Rob Sinclair, and he is the CAD manager for a good sized company called Civil Environmental Consultants. In fact, my wife works for them. But he teaches a lot at Autodesk University out in Las Vegas. And so he showed a technique that says, oh, here's how you fix this problem. If you get these little jaggies, what you want to do is go ahead and build your surface and get these contours like that, and then go in there and draw a smooth contour line over top of this where it's going to go, just sort of average it out. And then go in and add those contour lines to the surface.
Right.
Okay, well, that does the same technique, I guess, but really that's not exactly the same as doing this down here. It's going to be dependent on how closely you model what it is you intend to do through those sort of midpoint or the average location of those points.
Okay.
So he's teaching people how to fudge the surface stuff. And what we got to remember is contours are not the surface. Contours are simply a representation of the data underneath it.
Of what the triangles are actually doing, yeah.
Exactly, and the triangles are what make the surface. So you need to fix something to make the surface correctly. Now, that being said, in this article, I forget when it was written. 2010. So you see, there's some age on that. So Carlson has now, there's a switch when you're building the surfaces that you can tell it to automatically densify your break lines. So it'll do this stuff internally without hogging up your drawing with a bunch of points. So you don't have to actually go through and manually densify. You could just put the point across here, copy them up and drape them on the edges and leave it alone. And then when you build the surface, if you say densify the break lines, it will come in here and put these points in there so that the triangles can form there.
So when you densify, are you telling it like how much to densify, or is that just built in?
No, you tell it how, you tell it the distance between points. So this is like every 10 feet or whatever it is. And so you have to sort of get an idea. You don't want to densify things so much that you get a billion points that are not necessarily improving things.
That's going to slow your drawing down.
Yeah, and it just makes, well, the drawing itself stays without the points. It's just when it builds the surface. But then when you go to do things from that surface, it has to read, 20,000 contours in that, or 20,000 triangles in that parking lot versus maybe 5,000 that will find it better. So it's just, it's when you keep in mind that every time it puts a point down, when it densifies something, that point becomes a corner of a triangle. And so you get a sense of how many triangles you need. You don't need like, I remember Timmons hired me to do some work on the North Anna nuclear power plant.
Okay.
And they were trying to do machine control. And they had, I don't know, it was something like 40 some acres and, parking lots and all kinds of stuff going on. And they were modeling around the curb cuts and the corners. And they had just literally thousands of triangles around little structures that they didn't need. And it was bogging down their equipment. And they tried to load that surface on for machine control. So, we cut the densification back and still got the same look to the surface
Yeah.
and went on. So, those are some of the things that you're just going to have to know through experience, how to handle and all of that. So anyway, I'm not, I'm getting a little bit into the weeds here, but it's being able to recognize things like if you get a situation like this and it generates contours like this, and a lot of people say, oh, I got contours, good, I'm good to go. Well, that's fine. Or then they say, well, I'm going to smooth my contours. Now it looks good, I'm good to go, I'm going to hand it to somebody else. Well, if you hand that to, say, a construction company and they want to use the bulldozers out there with machine control, and if you give them your surface files that go along with this, they're not going to look at these contours. They're just going to take the surface file. And so when they go out there and grade this parking lot, it's going to have a nice little crease built right down the middle of it, which might be okay. That might be your intent for drainage. But if it's not, if you're wanting something like this,
Yeah.
then you need to make sure you understand what data is driving what result.
Okay.
So that's a case where you need to know how these surfaces are built and what the nuances are for what you're doing with that. Okay.
Okay.
All right. So let's load this guy. We'll come back to our. Oh, of course, I closed the wrong one. No. All right. Let's come back to this. Hang on. I've got this back. What did I do here? Let's see. Let me. Let's see what I can't get my cursor back over there. Let's see. Let's try that. No, got it over there. Let's go. Oh. There we go. Do that on that. This off. I'm back to that. Now I'm back, I think.
Yep.
At that, I accidentally said to put that on my iPad and it dutifully did it, and it was setting up in a different world. All right, so this away and I'll go back to this mess. Stop the share on that. And then back. share. Put this back up. There we go. Well, that's called having too much technology too nearby. All right. So anyway, so we've taken a look at a couple of things here under our settings with these project folders, the surfaces, startup settings is a default template that you might want to use. So you've got company templates. You know, you would set those up as your startup if you wish. And the project folder default, that's that starting location where your folders are all stored underneath.
Okay.
So you might have drive P for projects on your server, and then you say civil projects, and then everything under that would be, you know, ABC job or, you know.
Your individual project folders.
Correct. And then that builds those data structures underneath those locations, but this is where the top level, and you go down as far as you need to go to reach that top level. Okay.
Okay.
So that sets it up. Now it is right at our lunchtime. So we'll, instead of running you over and all that, we'll break and come back at 1 o'clock. And then we're going to talk about these general settings when we come back.
Sounds good. All right.
And we won't spend a lot of time here, but there's a couple things you need to be aware of because it's going to change the way things behave. And also to be aware that they can affect multiple users depending on what their settings are, because this is not a global thing. This is a per machine thing.
Okay.
And you're going to want to get everybody on the same page. And that's where you would come back down here to the top and do a save as and load and set all those things up together. All right. So we'll come back to that. I'll go ahead and stop our share. I will pause the recording. Hey, Jacob, you back?
Yes, Ken.
Okay, grand. All right, so over lunch, I went back and retried my Autodesk installation and it works fine. There must have just been something wrong with the server. So on their end. So I'm now in the AutoCAD version. I have set my color theme to light. You might prefer dark. None of that matters at all, except there are a couple of icons like, see this one right here. Hold on, I gotta. All right. You know, they're sort of hard to see because they're written, or when they were created, they were really not optimized for dark.
Right.
So I just like mine.
Do you know what toolbar that is?
Yeah. I'll show you that in here in just a second. Get this to go away. That toolbar there is on what's called the Carlson Draw toolbar.
Carlson Draw. Okay.
And it's Carlson Draw now, not AutoCAD Draw.
Yeah.
Because the AutoCAD Draw toolbar is this one here, line, construction, polyline, all different things that AutoCAD does. Plus I've got the multi-leader and the text toolbars from AutoCAD up here.
Yep.
And then I've got this Carlson Draw, and I've got the AutoCAD modified toolbar over here vertically on the right hand side. So now I'll show you where those are in just a minute when we talk about those. So if you want to match my layout, you can follow a little more closely. So let's go back into our settings menu, Carlson configure, and let's talk about these general settings and what effects they have. Now, if when you started up, if you've turned off that startup wizard, here's where you can turn it back on if you choose to use it. You don't need to. I just find it more helpful. It gets things started for me better. So I have it on. I also do not generate these logs. That just generates a bunch of text files that log everything that's going on. I don't find I need them. But I do save that drawing INI file. We looked at that earlier, and that keeps track of those files that are associated.
Mm-hmm.
Okay, and these are all pretty much self-explanatory. The ignore zero elevations means that when you select data to be used to build a surface, if it has an actual zero elevation, it will be ignored. And I
So
will,
if you have a 3D polyline with multiple nodes and somewhere in the middle, one of them you forgot to set an elevation for, it's just going to draw right across that instead of going down to that.
I don't think that's true. I think it will take that 3D polyline as an entity, and since it does not have a total zero elevation, I think it will use it and you'll get the whole.
Okay.
So you have to be, be aware of those kind of things. It's just that if you have line work like, a building outline or road center lines are typically drawn at zero elevation, and so those do not get used.
Okay.
And you don't have to worry about, freezing them off or deselecting them or anything like that, okay?
Yep.
And now the other thing to point out here is this checkbox right down here that says use software rendering. I have that checked on mine. You don't want to use that because you want to take advantage of your graphics hardware.
Mhm.
Since I'm running through a Windows emulator, that causes me problems sometimes on certain things. So I turn mine on for software rendering. It doesn't really slow it down terribly much, but it does a little bit. So leave yours unchecked.
Okay.
And now this set menu bar on startup, that brings up the menus at the top if you want to use those as well. AutoCAD menu, what to use. I just got regular AutoCAD, and that means if I choose from my toolbar or from my settings menu, there's this little red AutoCAD icon that will switch me into whatever choice I've chosen over here. Okay, so that's just some default behavior. I am going to use annotated scaling, so I have that checked on. And you can support all drawing scales. You can set annotated to the drawing scale if you'd like. And what to use for report viewer. I'm going to just use the Carlson viewer because it gives me some options. I can, dump the text onto the screen, those sort of things. Up here in the coordinate file format. Now this has to do with mostly if you do use a lot of Carlson points, particularly like surveyors. The old original numeric only, that means that the point records have integer numbers, 1 through whatever, and that was the old format. The alphanumeric means you can have letters mixed in with the numbers as far as point names go. That's a little more flexible. Plus, that file format is a random access file as opposed to the numeric only being a sequential file. So it can be, it can get large with a lot of empty records in it. Like if you got 1 through 10 as control points, and you got 1,000, 1 through 5,000 as your survey points, you've got records space for 11 through 999 that you don't need to be storing in the file if you don't want. So it's a little more efficient.
Okay.
This other thing, the SQLite, is a new format that allows any kind of GIS data that you may be collecting in the field, for instance, or even putting in the drawing. It stores that directly in the coordinate file. And you can see those data items when you enter the point editor. They show up on a different tab, but you have to have that particular format used to be able to see that. You can still use those data items, the GIS data items, but instead of, if you use the Carlson alphanumeric, it makes a secondary file, the same file name as the coordinate file, but it puts a GIS extension on it, and it just ties record to record as it needs to between the two files. So that's up to you if you want to choose, if you do a lot of GIS collection with your points, then that would be useful to have.
Okay.
Now, I'm going to skip over object linking for just a minute. We're going to talk about these other things down here. First of all, under digitizer settings, I'm going to say use a mouse so that it doesn't matter. I'll uncheck this tablet on for digitize commands. And there's only a few commands where you digitize things, like if you're digitizing drawn cross sections on a road, a set of road plans, for instance. And that's for back when the days when we used to have a digitizer tablet.
Yep.
We would tape the drawings down and we'd use the digitizer, and that would automatically turn it on and turn it off after you're done with it. But if you say use a mouse, then what that means is it's going to be expecting to see graphically on the screen, sometimes with a PDF file or whatever, and then you would just digitize by clicking on the screen. That's what we do most of the time. But to be honest with you, I've never done any digitizer work inside any Carlson edits, and I've been using this since 1983.
Okay.
I just don't find a need for it, but that's what that's for. Now, this part up here, remove arcs. And it's a choice as to how you want to basically densify what are, they're not in reality, but what are really, you know, arcs that have elevation along them. See, like on a curb entrance, you know, that starts at some elevation and goes through a horizontal arc in plan view, but in reality in 3D, it might climb up, you know, and change up to a foot or whatever difference in elevation. So to be able to use those things, there's no such thing in CAD entities as a three-dimensional arc. It's only an arc when you look at it in plan view straight down on it. It's part of that, it's part of a circle.
Right.
So if you were to take that part of that circle and hold down one end and grab the other end and raise it up a foot in the air, if you then look at that thing you've just modified in a perpendicular direction to that thing as it lies in a plane, it's no longer an arc. It has been stretched out. Okay, so even though in plan view, it would still appear to be an arc. So that's why there's no such animal as a true three-dimensional arc. It's not really an arc. It's a part of an ellipse at that point.
Right.
But we still think of them as arcs in plan view. Again, think about the, you know, a parking lot curb return.
Yep.
And so what we need to do if we want to use that structure, let's say we go out and we survey that on the ground and we get an elevation of 100 on one end and 101.5 on the other end. So we know it climbs up from one to the other. To be able to use that to model our terrain, we have to replace that arc with a series of connected line segments.
Right.
To sort of approximate that arc. So you can see if we draw, I'll cancel this. Just go ahead and leave yours up right now. I'm just going to draw a quick example. If I'm going to draw, say, an arc like this. All right, so that's a true two-dimensional arc. So to be able to use this, if it has elevations along it, then I need to be able to create some points or some segments that approximate that. So if I have, if I want to approximate that from one end to the other, I may go from here to here to here. And it does it with, you know, these are all evenly spaced. I'm just sort of eyeballing things like this now.
Yeah.
All right, so we have two means. We're going to say take this arc and replace it with three-dimensional arc or three-dimensional geometry that goes from this low elevation up to the high elevation, interpolates along the way. And we're going to use that to model the triangles, to model the surface. And so the method that we choose by default is either called maximum offset, which would be this distance across here, the maximum amount you want to allow any given segment to stray from the arc,
Okay.
or it's going to be the length of the segment. Okay, so that is what you're looking at here is which method do you want to use? I'm going to choose the maximum offset, and I'm going to say replace it with segments such that the maximum segment offset is 2/100ths away from that arc. Now, I think by default, it's something ridiculously small, like 0.0001 or something, which makes a really tightly defined replacement. But again, remember, every point along that replacement structure serves as a corner of a triangle. So the more you have, the more triangles. So, you know, over the years, I've found that that's been a good approximation for me. I can think of that in terms of a lot, you know, that a maximum deviation, I can live with that 2/100ths and be okay with it.
Yeah.
You choose to use the chord length, which it restricts the length of these chords to whatever, you know, whatever that length is that goes around. So if I have, you know, a very small arc, let's say that's only 2 feet from here to here, and if I replace it with, let me get another color here. If I'm using the, you know, 1/2 foot, I may go from here to, whoops, to here, to here, because that, you know, that's a 1/2 foot, a 1/2 foot, or, you know, or maybe that's a 1 foot arc. But you can see I can get, so depending on the amount of curvature. So if this, you know, arc was really tight, you can see that, you know, this, you could wind up with a lot greater deviation from the arc. So that particular setting using the arc length is more susceptible to the degree of curvature,
Right.
than the other method. So, but it's just a, you know, it's whatever you want it to be. So now if I were to have done that, you can see that my deviation is a lot better because the curve is flatter. But these sizes of those segments would remain whatever that setting is. Okay, so that's how that goes. It's just, again, my experience and my preference is this maximum offset controls the deviation better than this chord length does. But the chord length also limits you to the size of the triangle, whereas this 0.02 might make more triangles, but I've just found that to be a better setting for me.
Yeah.
Now, this part up here, object linking. What this means is if you link points, that means points in the drawing, with your coordinate file, the external file, that means when you move a point in the drawing, it's going to update the coordinate file automatically. Also, if you edit the coordinate value in the coordinate file, it will also update the point in the drawing. And sometimes they get out of sync, and there's other tools that you can sync those back up as well. So, but that being on now, it used to be that this happened all automatically and it never gave you any warning. So if you did not have it on when you created a point and then you moved that point, well, the point changes in the drawing, but it doesn't change in the coordinate file, and it didn't tell you that. Now, because that was always such a problem, they have warnings that come up and say, hey, it's different. Which one do you want to use? So that one is less problematic than it used to be, but I usually like to leave it on. Now, if you link line work with points, that means anytime you draw line work with any of the Carlson commands, that instead of just prompting for points that you click, 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 or type a coordinate value in, you can also type a point number in with the Carlson commands, and it will use that coordinate value of that point number. And if your line work is linked to the points, then if those points change, if you move a point, it will recreate the line work and make sure it still goes through that point.
Okay.
If you don't have that on, you draw through a set of points and then you move the points. Well, all you've done is just change the point position. The line stays where it was originally created. All right, so that's there for use. Linking labels with line work. And these labels are when you do any type of annotation from the annotate menu.
Yeah.
Like bearings and distances or areas of parcels, anything like that. If the line work changes, it will automatically erase the old line labels and recompute and redisplay the labels in their proper positions.
That's pretty useful.
Yeah, it surely is. Although it can get in the way sometimes, particularly with surveys, like if you are, drawing in the meets and bounds on a parcel and it's matching up with the deed, but then you have to tweak it a little bit to match field positions, but you don't want to change the deed the deed line work labels. If you have that on, if you move that line work around, it's going to redisplay that. So, but for us, particularly with civils, we usually want to keep that linked. And then link line work with center lines. And this has to do with when you draw a polyline and you want to use that as an alignment, you turn it into an alignment file, a center line file. Then when you double click that drawn polyline, as long as it was created as a center line, it will automatically open up the centerline editor. And also, if you change the graphic drawn centerline, if you just take a grip and move the grip edit, it's going to go into that centerline file and recompute and redisplay the data as if you had made numerical changes. And I'll show you how that works in a little bit as well. All right, the last two group point entities, that has to do with the Carlson points. And the Carlson point is composed of 3 different entities. A Carlson point object contains a CAD point, which is almost always at the insertion point of the symbol. And then it contains the symbol, that's a graphic block. And it contains a second block, which is this label, the point number, elevation, and description. Okay, and so that CAD point, you may refer to those as nodes. You've heard that as a snap mode as well. So here's an example of using a Carlson point where you're not also using the node. You can turn that on and off. And here's one where you have it where the node displays, and this X that you see is the AutoCAD point display mode, this PD mode variable. Okay. If you make it blank, it doesn't draw it. If you leave it by default, it actually makes it a little dot like right up here.
Yeah.
Okay. And of course, you can have it with whatever symbol the PD mode is set to display as well. But that's different from, say, a drawn X, if that's what you choose as your symbol, instead of, say, that triangle. Carlson can put those in as well, but when Carlson does it, it puts in this as a graphic block that's composed of drawn line edges. And so if you have your endpoint snap on and you try to snap to that, it might grab the corner here instead of the actual point location. So you have to be careful. When it's an AutoCAD PD mode variable that is set that X, well, it won't let you snap to those geometry points. Only the node itself is snappable.
Right.
Okay, so that's just something to keep in mind. Now there's a little warning note here about a problem that it had in IntelliCAD, which didn't match. Now they've since fixed this since I pointed this out, and so you don't have to worry about it. You're not using it, but it was just amount of display of the decimal points.
Yeah.
All right, so up here, we're talking about using points. And the biggest advantage that we have is when we have a bunch of points that define our geometry already done, we can use point numbers, and we can use a range. So that means go to 5, 6, 7, all the way up to 13, 21, 22, 23, 24, 25, 30, 35. So I could put this in as my answer. When I say draw a polyline, I could say 5-13, 21-25, 30, 35, hit enter, and it follows all of those numbers and those ranges. It goes, these points, and it jumps to 21 to 25, jumps to 30, jumps to 35 when it creates it. So that is the chief advantage that we have, is we can use those to control our drawing. So let's go through that and see how some of this stuff works, some of those settings. I'll show you. So once you've got this stuff set like this, go ahead and choose OK and choose exit. And we'll come back in here to airplane drawing. So let's go to the points menu now, and let's choose set the coordinate file. And we'll look in our civil class folder, and we're going to choose that exercise 1 coordinate CRD, and make sure you're on the existing tab up here at the top. Choose that exercise 1. It shows you over here. You've got 22 points in there. And you've now created that as your coordinate file. Now, they're not in the drawing yet. But if I go to points menu and list points, choose all, you can see there they are. They don't have any descriptions, but they have X and Y and elevation. Okay.
I'm sorry, could you, where do I get to that menu? I did this, I set the coordinate file.
And I chose the points menu again, list points.
Okay. And then select.
Yeah, you've got your selection up here. You can list only a few of them, or you can buy a group, or I just hit all. And
none of that's checked for me.
Yeah, you can turn on these, and there was job header that was in that job setup down at the bottom where you could put in job number and all that kind of stuff. You could list GIS attributes if you had them, things like that.
Okay.
And the report formatter is a different animal, and you can even include geodetic reports, which they won't be meaningful here, but in your geodetic option, you can tell it to, if you need to do any datum conversions, you could. The amount of degrees, minutes, seconds, precisions you may want to use, whether it's decimal or degrees, minutes, seconds. Say okay and say okay. Now that's going to come into this, and you can choose the different things you want to see, northing and easting and elevation. And then let's put latitude and longitude in. And now, if I hit this display, it goes to that standard report viewer. And it computes, I've got a northing and an easting, and then it computes the latitude and the longitude for each of those points. Just as an example, and that's why using the report formatter. And you can also, put that into a spreadsheet. You can kick that out to Excel. You can put it in HTML if that makes sense for you. You can make a table entity so that you can then, when you exit the viewer, it's going to ask you to pick a location for the table. I'll put it right there. Say okay, and there's an AutoCAD table for you.
Okay.
All right, so those are some of the things that you can do with that as the report formatter. But typically, like I said, I don't use that report formatter. I just use the standard viewer and say okay, and I get this. Now this is It's a text file. I can save it. I can print it. I can edit it. And I can dump it to the screen, and it can be, let's use mtext, I'll put it right here, for instance, give it no rotation. When I exit, there is now an mtext table. I can set the fonts and do all kinds of things with it. All right. So now, so we have these points in our coordinate file. We see it when list points, but there's nothing in our drawing yet. So to get them from our point file into our drawing, we have to go to the points menu, and we're going to draw locate points. But before we do that, let's look at the point defaults. And here's where you're going to turn on whether or not you want to display the descriptions and elevations. And you can put a prefix and a suffix on those elevations. Like you might put AMSL, above mean sea level, or whatever you want to put, or just put a foot mark, whatever.
Okay.
And locate on the real Z axis. Now I like to do that. When I have a point that has an elevation, I like it to be at that elevation. Other people don't. It still reads the elevation when it needs to use it for something, but it leaves it down at 0.
Right.
So, and then my attribute layout ID, I chose that number 2. There's the default number 1. You know, there's where it lines up everything on the side. That just, I like that better. You can choose a symbol again. And then down here is whether you want to use the point numbers and automatic point numbers. And that means if you're creating points, it's going to automatically go to the next one from wherever you start.
Mhm.
Okay. So it knows there's 22 points already there. So the next one would be 23. It gives you a layer to put them on. And that is the layer that the block, that point block gets inserted on. That's its parent layer. Now that block also has elements in it that are on specific other layers. I'll show you that once we get them drawn here in a minute. And then here's where you can tell it whether or not you want it to also draw the point node, that AutoCAD point. And if you want to use annotative points, then that means if you're using drawing annotation, they will change automatically for you. Otherwise, if you change scales, they'll stay the same size. Okay, masking the point attributes, that will, you know, put a wipeout behind it so you mask out other stuff so you can see them well.
Okay.
You can also use field to finish for point styles and where you're going to put them, which layers based on the description of the points. It's not going to apply for us now, but if we were to do it, then it would ask us to choose a code table, and you could have a GIS file associated with it. You would set that here, and it would link GIS data to these point locations. All right. So that's our defaults. Now we come back to draw locate points, and some of these we can override from the defaults. Like you just say draw nodes only, it wouldn't draw the symbol and the attributes. But we'll go ahead and do, we'll leave those unchecked, and you can limit the points that you choose within certain perimeters or distances or ranges. And then what all do you want to show up here? Descriptions, elevations, locate on the real Z. And we use a negative for negative elevations. If I have any, I will label 0. So if I have a 0 elevation, it's going to show me 0.00. Use my point numbers again as well. I can limit, if I say all, but I put a wildcard description in here that says, I want to do, you know, CTRL. Let's see, CTRL asterisk, then anything that starts with a CTRL and anything else after it would be chosen and other points would not be. Okay, so don't have to know what they are if I know that my descriptions are. It's sort of like using a group. Okay. Any duplicates? If I have points already drawn in the drawing and maybe they're not already in the coordinate file, or if they are, I can allow duplicates. So I'll get two at the same point in the same location. Or I'm going to say erase and redraw, or draw only the new ones. So if I erase and redraw, if it's already in here, I'm going to redraw. I'll erase the ones that are here, but redraw them from the coordinate file. And again, here's my layer that I want to put them on. All kinds of, filtering that you can do. And I'm just going to say draw all. See the different choices down here. Enter and assign means it's going to ask you for coordinates. Screen pick means you're going to pick a point on the screen and it's going to ask you for the description and elevation. But if I say draw all, they're going to read the coordinate file and you're going to put them all in my drawing. Right there they are. And then it does a zoom to the extent of the points is generally what happens.
Okay.
So now I've got a bunch of points, and if I double click this point, it brings up the point editor for that particular point. I can change these values, change the symbol, add notes. Here's where I had GIS data if I had that other format, but I don't. I can associate an image with that. Maybe I took a picture out in the field to help my field crews find that point. And then I've got basically how many decimals do I want to see in the editor. That's how many I display here. As well as my elevation decimals. Now, here's the description. I can have a description for this point separate from, or the description of the drawing. Let's say I'm going to call that maybe that is a iron pipe set. Okay, and that's what I want it to label in my drawing. But I may have that as my coordinate file description. And if I say, okay, you see there it is. And if I look at my points list in the coordinate file, if you look at point number 17, you see it says IPS. But in the drawing, it says iron pipe set.
Okay.
All right, so that, just understand they can be two different things. You can also say non-surface. So let's say that was the top of a fire hydrant. So it has an elevation and I want to use it for other things, but I want to say non-surface. So then if I select it as part of my data to make a terrain model, if it is marked as non-surface, it will not be used in that terrain model. So I won't get that little bump up at the top of the hydrant.
Okay.
All right. So now, and again, you can see if I were to redraw these points again, this erase and redraw, if I say draw all, you're going to see 17 come back in and say IPS because that's the description it reads from the coordinate file. And if I needed that to be different here, I would set it different here.
So wait, previously you had typed that out in the drawing description, and then you had them, you had them different, right? So the drawing description said the full expansion of that.
Yeah, like that right there.
Right.
Now, and so all I did was I edited this point that's in my drawing, and in so doing, it also allows me to edit the description in the coordinate file.
Right.
So this could actually be blank.
Okay.
And this is what it is in the drawing. Okay, or they can both be blank. And right now I'm just going to turn them both blank so that they're no longer there. And you can see it has taken them out of the point description. There's point 17. There's no description anymore.
Okay. So when you redrew the points, did it automatically change the description to be the abbreviated?
Yeah, because I said erase and redraw.
Yeah.
So it took that original point and erased it out of there and reread the coordinate file. And the only description it sees in the coordinate file is that IPS. And that's why it printed IPS there.
Okay. So if you were to create a drawing description and a coordinate file description, and they were slightly different from each other, say, drawing description is written out and coordinate file description is abbreviated, and then you decide to redraw all of the points using the using the erase and redraw, it's going to read it from the coordinate file.
That's correct. And it would erase it out of here and put the coordinate file description in.
And
So
then when you double click on that point, then both the drawing description and the coordinate file description will match each other.
right. So if I had this situation, and if I wanted to keep that, then when I locate my points, I need to say, draw only new points. So see, it was already there, so it did not erase it and redraw it. If I had other points that weren't in it, it would put them in, but because this was already here, it left it alone.
Okay.
Now, in this particular case, they were all already here, so it left them all alone. So you see down here at the bottom, it says it drew 0 and skipped 22.
Right.
All right, so set this back. I'm going to have to take this one column.
Yeah, sure.
Okay, sorry, Jacob. That was my car's in the shop and they're saying they're running over. They're going to take it another day and blah, blah, blah. And it's going to be a problem anyway. So now let's, if you got your points in there, let's talk about what, how these point numbers are going to be useful and what we can do with them. If we go to that, we've drawn our points, but let's say now and even if we haven't drawn the points, in fact, I'll select all these things and erase them. Now, all I've done is erase them from the drawing. They're still in my coordinate file. So now if I go to my draw menu and draw a 2D polyline, and I'll just say use the current drawing properties. That means it's going to be on the layer 0 and color and all that kind of stuff. And I'll say, okay. And it says pick a point or point number. So I can say, click around in here and draw some things. And then I might say 1-5 and hit enter. So see, it went up to point number 1, 2, 3, 4, 5, and it's still part of my command. And now I might say 10 through 22. and it finishes up. I'm done. I'll hit enter to finish. And there's now my drawn polyline, partially drawn with points. And I'll show you that by draw, locate points. I'm going to just draw them all again. So there you can see I drew out here, and then I went 1, 2, 3, 4, 5, and then I went 10, 11 down through 22. Okay, didn't use them all, but use some of those.
Yeah.
Now, remember our link line work with points. So if I select this point number 13, first of all, tell me what you get when you select that. Do you get these 4 grips, or do you get a single grip and a rectangle?
Single grip and a rectangle.
Okay, so that is a setting, and you can leave it like that if you want, but when you choose that and you can move that 1 grip, that'll move everything together as a single unit. But under, I'm going to right click and choose options, and it's under selection on that selection tab. There's a box right here called object grouping. And that means if it's in a group, which that is, it's going to, when you select any one object in the group, it just puts it together and treats it as a single object. I've turned mine off because I like to have this here so that if I wanted to, I can rearrange, some of these attributes individually without moving the point location.
Yeah.
But if I also grab this middle grip right where the point is, that's going to take everything and move it. Now watch what happens to the line when I do this. So it's now been moved. And if I double click that, what happened? Oh, it didn't update the location. Let me see something here. All right, if I select this point, let's say I choose move. I move from here up to here, so that's going to move the entire. See, it's not behaving. Let me see if I have to do that. This is a difference in the AutoCAD version.
Okay.
Let me see if that's the case. So if I select this and then move, so that's going to move the whole point. So do you want to update the coordinate file? Yep. And so I moved that. And now when I do a region, wow, it's supposed to make that one slight change here. Do that. Yeah, this works. Huh. It's only selecting that. So now if I move. All right, I'm going to draw point 13 again. Wow, that's only moving the attribute. That works differently here. Let me see if I can. Group point entities. Let me turn that on. Still only doing that. If I do that. Wow, that line's supposed to go with the point.
I'm having the same issue.
That used to work. I don't, it might be something they broke, the update. So when that point moved, this line should have gone out with it.
Right.
Let me put that back. Now, what happens if I just move it down 6 feet? Yeah, that should have automatically updated to that location.
I'm not even getting the prompt for updating the coordinate file.
Is your symbol in a different place, or is did all you move was?
If I just select the symbol, it only selects it as a block. It doesn't seem to be linked with the point itself.
Wow, I don't understand. So that brings it to polyline editor. Okay, so if I were to move no, it's broken. I don't know why. In the IntelliCAD version, it will follow. Don't know why. The linking isn't working for that. Well, that's unfortunate. I guess we need to let them know. Are you using 2022 or 2021?
We're actually on 2020.
And you're still not getting those updates?
Well, I mean, our owner wanted to hold off on updating to 2022 until some of the kinks were worked out.
Oh yeah, that's fine.
Just like with any, any software update. But yeah, so if I select the text, I've turned off the grouping in the options.
Okay.
If I select the text, it selects everything like it does there. And when I move it, it just moves the information.
Right. It just moves the block of attributes. It does not get the point.
Right.
And so now it used to do that. It's supposed to be able to do that. And in fact, what I did is I did this, and when I select that, you see I've got 3 things that I've selected.
I see.
I've got 2 blocks, one of which is the symbol. The other is the attributes, the labels, and there's that point. There's just a dot. That's the point entity. So now I've got all 3 of these done. And if I say move, now when I move it, I'm going to get that prompt.
Okay, so I've tried that and I'm still not getting the prompt for some reason, but in the configuration, I have the object linking set.
for link points to coordinate file?
Yes.
And that was set before you did a draw locate points, right?
No.
Okay, so that could explain that. Let's erase all your points. Let's go to the points menu
Okay.
and choose erase points.
Do I need to worry about erase attributes or just erase points?
No, just use erase points. And now it asks you to select the points from the screen, a group, or by point number. Let's just choose by number, and let's just type the word ALL for all. And then when it says delete points from the coordinate file, say no.
Okay.
And then delete points, yes. And now they're all gone.
So erase points, number, all, no. Delete point symbols, yes. Okay.
All right, so now making sure that the linking of the points and coordinate files is on.
Yes.
Now, when you points, draw locate points, draw all. Now, when you do that, select a window around it and move it, you should get that prompt.
Oh, that's okay. So 2DP, all right. Okay, so now let's try that again. Okay, now it's asking me to link or to update the coordinate file. Okay, yes. Okay, so when I said I want to update the coordinate file, click, it popped up a little message that asked if I wanted to disable point links.
And I would say, no, you don't want to disable those.
Oh, and the line actually jumped to the point when I moved it on my screen.
All right, so if I move this point to here, update coordinate file, yes. But see, I don't get that update links. But yours is working now.
Yeah, it seems to be when I moved when I clicked yes to update, and then the little box came up and asked if I wanted to disable the links. I clicked no, and the polyline that I had drawn followed the point where I had moved it to.
All right, well, that's working the way it should be on yours. I wonder what the heck is going on with mine. Again, it could be something that they fried in 2022. All right, well, anyway, you see how that works.
Yep.
Now, let's do a couple of other tools here, and I'll show you some of that other linking real quick. I'm going to go to the edit menu, come all the way down here to Polyline Utilities, and I'm going to say down here to remove polyline, and I'm going to say remove polyline segment.
Okay.
And I'm just going to take this segment right here out. So now I've got this polyline separate from that polyline.
Yes.
And I'm just doing that so we don't get these little ones in here. So now if I annotate that, annotate menu, I'm just going to say auto annotate.
Okay.
I'll wait for the dialogue because it's pretty heavy. I'll just take the, I see it's going to be distance and angle both over the top. So I'm going to go over here to the top and say, I want the distance and angle both to be on the same line. They'll be above and above at the same row, 1 and 1. So they'll be side by side. You could do it if you wanted that to go below, it would look like that. So you get a little preview. So I'm going to say, okay. And I'm going to choose that line that I drew. Okay, the polyline, and it's labeled the bearings and distances. Now, even like this had that coordinate point, but these points are just graphically drawn, which doesn't matter. All I have to do is change that. You notice these follow.
Yep.
And recompute the different distances and bearings. Okay.
That's great.
Same thing would happen with area labels and all that kind of stuff. So that's what that linking does as well. Now, to show you the.
So that would be pretty useful for, say, like once you do get into hydrology, if you're delineating drainage areas to structures and you need to change something.
Yeah, you get your areas will update and all that.
Rather than having to re-annotate each time you adjust the boundary of that drainage shed.
Exactly. Exactly right. Now, I'm going to go in here and select everything and delete it. And let's talk, I'll show you one more thing on the linking that will also show that. We're going to draw a polyline. So I'm going to draw a 2D polyline. I'll just again keep it on my current drawing labels. I'm going to come up here to the top. I'm just going to leave it at elevation 0. So you can make a 2D polyline at a given elevation, but this is just going to stay at 0. And I'll say, okay. And I'm going to just click a point. All right. And now looking at my options at the command line, I'm going to type D for distance, and I'm going to go 125 feet. And it wants to know, how do I want to, where do I want to go? I can either, if I just move the cursor up here, and if I type C, it's going to go where the cursor is. It's going to go in that direction, but only for 125 feet.
Okay.
Okay. And now it's still in distance mode. So I'm going to just at this point say Q for quit. And now it's back to drawing the polyline. I'm just going to graphically pick a couple of things here. And then hit enter. Now, this could be a series of, say, manhole locations, and that would be an alignment for that manhole layout, or it could be a road. Obviously, we don't have curves in here yet, and you can do it several ways. You can just put filleted curves in. You know how to use the fillet command, I'm sure.
Yep.
So you could do it that way, or you could go, let's go to the centerline menu and choose polyline to centerline file.
Okay.
And we're going to give this a name. We'll just call it test. And it says select the polyline that represents the center line. Well, it says polyline should have been drawn in the direction of increasing stations, and that's okay for me.
Mm-hmm.
If not, it gives you a chance to reverse it. So I'm going to pick that, and it shows you the direction it was drawn. One of the options is to reverse, and you can set your ending station, your beginning station, or anything like that. So I'm just going to take the default begin at 0, 0. And it reads it, creates the alignment, tells you a little bit of what it is, line intersection, line intersection, line intersection, press enter to continue. Now, I've done a center line. There is a center line file, and I could go to the center line editor, load up the file, and do all that. But because I have it linked, all I have to do is double click it, and it brings up the center line editor.
Could you go back through the menu to how you got to
that? Do you have this drawn yet?
Yes. Yeah.
Did you turn it into a centerline file yet?
Yes.
All right, so there's there. All I do is double click it.
Okay. All right.
And whichever segment you double click, that's the one that comes up. It sits on that segment. Okay. Now, let's say here, I'm sitting at this line, I go to that line, but this is basically my incoming tangent, and I want to fit a curve. So I can fit a curve in there, and I could give it a particular radius. I'm going to give it a radius of, say, 35 feet. It computes everything it needs to be. I can also look up horizontal speed tables and do all of this kind of stuff for good highway design, etc. So I just gave it a value of 35, and I say okay. And you see it puts a curve in here. All right, and I'll say save. And when I exit, look what happens on the screen. Okay. And not only that, but if I just do a simple, let's do a fillet curve. I'm going to do a radius of 50 feet. I'm going to go here to here, and I'll repeat it. I'll do another one over here. Okay. So now I've changed that. Now watch what happens when I double click this. You see those curves are now in there.
Okay.
So that's the linking. It doesn't matter that I have made the edit in the editor or made the edit graphically. It updates the centerline file, and the centerline file updates the drawing. Not only that, if I go to centerline and if I said station, the polyline centerline, and if I go to make sure it says centerline by centerline file, and I think the default will be fine. I'll say, okay, I'm going to choose my centerline file. I'll hit open, and there's now my centerline labeling. Now I'd probably need to adjust some of these settings,
Yeah.
which I can do. But if I were to edit this, let's go back to this curve, and let's double click that, and let's make that a 40 foot, and let's make its length. Let's change its length to say 65 feet. Make sure that my whole PIs, no, let's hold the PC point there. Say, okay, now I've got a bigger curve, and it's going to show up different stationing. And I say save and exit. You see it not only updates the drawing, but it updates the labeling as well.
Yeah.
Okay. So that's what all that linking does for you.
Okay.
And that's really all the time we need to spend on our settings, but those are things that are important to know, particularly with that point moving and updating, because a lot of surveyors, I had a class down in North Carolina I taught years ago that before that little warning popped up, that this surveyor, I had like 12 people in the class, their manager was in there with it, and we talked about that, and he goes, oh my gosh, I think that might explain our last 2 lawsuits. I said, what are you talking about? Because I want everybody to get up right now from class and go back to your office and look at your individual machines and tell me what that setting is on yours. Well, sure enough, some people had it on, some people had it off. And what happens is some of the surveyors like to work in the sense of like they'll dump a bunch of points in the drawing.
Right.
Knowing that the coordinate file holds the right values. Well, then let's say the points are in the way of something and they zoom in tight and they get a bunch of stuff. And so they just start moving things around because they know they can go back to the coordinate file and fix it. And so they're moving it, not a whole lot, just a little bit to get it out of the way. And then
it's updating the coordinate file.
Yeah, because what happens is the point gets put in the drawing with the setting that is active at the time the point gets done. So if somebody else put the point in and had the update on, and then another surveyor comes in and he loads it up and he's going to move it around because he's used to it not being linked, it doesn't matter. It was created with the linking on. He doesn't know it. The warning didn't pop up. And so they were moving the location of property corners, a little bit, just a little bit at a time, but they got into some lawsuits over ownership issues. Yeah. And they weren't aware of that. So
wait, so earlier when we were talking about the general settings, you had mentioned that the general settings they're machine specific, not global, right?
That's correct.
But even though they're machine specific and not global, because the points were inserted into a drawing with that setting turned on,
then that's the behavior that point has from that point forward.
Even though someone coming in behind them may not have that setting turned on?
That is correct. Remember when you drew yours and you weren't getting the update prompt?
Yes.
Because when you first drew them, your linking was turned off.
Okay. So it's not, they're not, the general settings aren't global in the sense that it affects everyone, but the information in the drawing is still tied to those settings, to whatever the settings are when they were first created.
That is correct. So they are static in that sense. You change the setting and it only applies to things from that point forward. Anything that was done before relies on whatever was in effect at the time it was created.
Okay, because as far as the DWG is concerned, it was drawn with those settings, so it still has those settings.
Correct. Well, yeah, but I mean, you can go in after they're drawn and change the setting, and it doesn't matter. The thing was drawn with the settings set the way they were at some point in the past.
The setting is kind of embedded into the point or the center line.
Yes, it goes with the object, and it only applies at the point of object creation.
Okay.
All right.
Yep.
So anyway, that's about all that we need to fool around with in that regard. Let's see where we can skip ahead now. Point groups. All right, I will show you this one here in a minute. I'll let you work through this point group exercise on your own time. It's just a matter like when you're basically we dropped a bunch of points on all of these corners, and we did that automatically, and then we turned the point number, elevation, and description off and only drew the symbols, and we said draw locate your points with this circle symbol, and it just plopped in these little circles all the way around, but they actually are coordinates that are drawn in the drawings. It was just a quick, easy way to, to sort of in one shot draw these corner points, and so you're not having to snap to the end point of each one, for the entire subdivision. It would just draw those in together. So we'll leave that to another day. Now, so let's talk about this terrain modeling. And you've already told me about some things that you're aware of, which is good. A lot of people work through things and they don't really understand this. And sometimes, oddly enough, the surveyors are the ones that don't get it. And, the danger is that they're not, they don't really know about the use of break lines and how break lines are controlling how the triangles are formed. So I'll let you read all of this mess over here, and it talks about the dangers of thinking that contours are the surface, and really contours are just a picture of the surface. The surface is actually the model, the triangles themselves. Okay.
So if, I guess the way, let me think of how to word this.
Okay.
Back in the first example that we were looking at with the parking lot, and the contour smoothing and the densification, you're reciting an anecdote about the gentleman who would fudge it by drawing a 3D polyline at the contour elevation that he wanted.
Yeah.
And updating the surface with that contour added to it, and it would kind of have the surface contour adjust accordingly so that it looks correct. But that's not actually updating the triangles.
No, that updated his triangles, but it updated it along those drawn contour lines. Whereas, and let's say you've got hundreds of contour lines to draw, that's going to take you forever. Whereas if you fix the data that generates the contour lines in the first place, they'll take care of themselves.
True.
But it's in the case of when you smooth contours to try to make it look pretty,
Yeah.
you're not changing the surface at all. All you're doing is changing the drawn contours. So now if you were to smooth your contours and then go back, say in Civil 3D, and add those contours to your surface, that would update it. But again, it updates it along the contour lines. And that might be okay, but it doesn't, but that would overwrite any little local differences in between the contour lines. Okay, so you still have that issue.
Right.
But so the thing to remember about all of this with Carlson, you know, we're going to be doing a process called triangulation, because a triangle is the most basic figure that we use to form surfaces, because it takes a minimum of 3 points to make a plane in space. And so you make a triangle with 3 points, and then you put it next to another triangle with 3 points, and it shares 2 of the points with your original triangle. And edge to edge to edge, it all stitches together and it approximates that surface. Okay, so there's that edge to edge bit. And anything in Carlson, when we select data to triangulate, all it's going to be looking at is 3-dimensional information. So if I've got a 3D polyline, if I've got a 2D polyline at elevation non-zero, if I've got points, if I, you know, just plain old point entities, or even Carlson points, anything that I have, it's going to read its elevation and it's going to create a triangle corner at that point. And then it's going to look at, and it here, of course, every edge from a triangle, it's a line of linear or constant change from that point to the other point of that triangle. It doesn't allow for any change from that constant change between points. If it is, it makes 2 triangles instead of 1. Okay. So when we're building our surface, what we need to remember, the basic rule to remember, is that every point can see every other point around it. And it can possibly choose to form a triangle edge to any free point, that as long as there's nothing in the way to block that line from forming. So if you take a look at this simple 4-point example, I've got 100 down here, 110, 100 over here, 110. That could be one of 2 things. That could be a ridge at elevation 110, which falls off to the sides of 100 feet on each side. And that, in fact, is what happens with the triangles the way they're drawn here.
Yeah.
If, however, that is not the case, maybe it was instead, here's those same 4 points, but it's a valley bottom with elevation 100 to 100, and it rises up on either side of that valley bottom to 110, 110. Okay, but this triangle couldn't form in that, and that would be, you know, the upper left to lower right triangle. That couldn't form if this triangle formed first, because this line forms as a triangle edge. It now blocks this triangle from seeing this point. It can no longer choose to go to that point. It has to go to something else.
Right.
So whenever we know we have a condition that we want to keep this point from seeing this point, we have to draw in those edges, those break lines.
Yep.
Now, here's a classic example in the surveyors. And a lot of times surveyors will do this. They'll go out there and they'll shoot the back of curb, the top of curb, the face of curb, the edge of pavement. They'll do it all along one spot. And then they'll go up, you know, 20 feet away and they'll do the same thing. Well, that's okay. And it probably would work just because of proximity rules. But you also run the risk of point A, for instance, being able to look up here at point E and there's nothing in the way in our data. You know, this structure hasn't been drawn yet. That just shows you what it is. Or point B could look up here and see point G. And so it makes a triangle. So you wind up losing the definition of that curb structure.
Yeah.
So, what you have to do then is, and here's an example of that case. Here I've got some invalid triangles. A looking at E should not be able to do that. C should not be able to look at G.
Right.
But C can look at F and E and A. Those are all valid. These are invalid. So we have to draw that geometry along that feature. We have to draw that in as a 3D line work ahead of time before we build the surface.
Yeah.
Or again, you can do it after the fact, but you want to have it in there beforehand. And so if we do that, you'll wind up having the triangles form like they're supposed to, like A, B, and C, C, E, and F, and then F, G, and E. Those now form the proper triangles in the proper configuration, okay? So that's what we need to talk about, is to limit the visibility of those points. And here we'll talk about a couple of other things that we're doing. Sometimes, the data that you had to start with might be coming from a data file of a bunch of points. This is actually from a DEM that came out of a USGS quad sheet, and it's on an evenly spaced grid, but they all have elevations, and so that could be used to make that surface as well. But the key thing to do is to evaluate the data. Take a look at it before you just haul off and make a surface out of it, because you can tell a lot of times what happens. And here's a case of, say, a photogrammetrically compiled site where these are all, break lines that they configure, and these little X's are points that they just drop spot elevations on. I've got road edges, parking lots, things like that. And if I look at it, if I look at it beforehand, before I do it, and if I spin it up in 3D and I look at it like this, I can look at that and say, well, everything looks to be, at its proper elevation, whereas sometimes you'll get situations like this where road edges are down at 0, and they're not contained up here. So you have to take these edges and drape them across this data and get them to lie where they're supposed to lie. And now they'll be able to keep the points on, one side of the road from looking across to the points on the other side of the road, and you'll define that much better. Same thing with the stream center lines, okay? So we're going to take a look at that. We're also going to take a look at putting boundaries around our data, because anytime our data, which follows, say, this where my cursor is going, that's really the extent of that data. But these points out here, when it's modeling, if I don't limit its visibility, it can freely look across to the other parts of the data and say, I'm going to build a triangle out there.
Something I'm constantly dealing with.
Yep. So you don't want to have it do that. Now, there's a real quick sort of way to think about this. If all of your data set is in, if you don't have any insets into the data, this won't be a problem. If everything is sort of square and looking, let's say in this example over here, let's say you had data all out in here, but it all formed, everything was convex, and there were no concavities in your data, you don't need to worry about it. But in this case, we need to do it, and you can either delete the triangles or you can draw the boundary. There's all kinds of tools. You can limit the length of the triangles to get rid of these long ones, but you get these short ones.
Sure.
So, we're going to take a look at some tools that we've got, and a lot of them are automatic now. You can turn them on and off and have it do it automatically, or you can do it yourself manually up front, which I still do a lot of that as well. And so, again, the key thing right here is, use your eyes, think about it, and then use the tools to make sure that you deliver what it is you intend to deliver, okay? So we're going to open up a drawing here in your drawing set, and this is an actual photogrammetric data set, we're going to sort of step through all of the little nuances of modeling terrains and some of the dangers you can encounter and some of the tools to fix those, and to evaluate the data that you're given and figure out what is the best data that you have. Obviously, the best data to get it from somebody else is to have them give you their surface that generated their contours. If they don't, and all you have to go from are the contours, then sometimes it's all we have. And we need to fix it if it's a problem. Okay. And we'll talk about that in a minute. So we're going to open up that sample from T3 Global. So I'm going to go back to Carlson here, close this off. And then I'm going to open this sample from T3. So I'll hit my open and I'll go to my 0407 civil class. That's it. I'm going to scroll down here and find sample from T3 Global and choose open. And I'm going to ignore any missing shape files. I will show proxy graphics, but I don't know where this has been in and out of different software. So I've got some things there that don't really apply. And you should see something like this. And then you should also notice immediately that I don't have to worry about the boundaries out on these edges so terribly much, but I do have this little inset here, and I've got this inset down here at the bottom.
Yep.
Now I see I've got these points, and they're just points. They're just CAD points. And that came from the photogrammetrist, and you can see they're on a pretty close to an evenly spaced grid. But I also have a bunch of these little drawn lines like this. And these are all 3D polylines, and those are actually the break lines that they used in conjunction with the points to create the contours that you see drawn here. So again, remembering that the contours are just the end result. They're the output of that surface.
Yeah.
If I'm going to build this surface, my best source is what they use to build the surface with, if I can't get the surface file. So I'm going to go to the view menu. I'm going to choose down here, isolate layers. And I'm going to pick one of those white lines. And I'm going to pick one of these magenta colored points and hit enter. And that should limit that display to just that data. Okay. And I'm going to look at that in 3 dimensions and see if everything looks good. Now, I got 2 ways of doing that. I can hold the shift key and then press and hold the wheel on my mouse and spin it up, and then use the wheel to zoom in and out and sort of lay it around. And I can sort of get a sense of what that looks like. And it looks, you know, pretty decent, like it defines what it is I'm going to be doing.
Yeah. The 3D orbit is probably one of my favorite things about this.
Yeah, and now, but one thing is that sometimes, you know, people forget that they don't go back to plan view or whatever. So Carlson has a 3D viewer that has a lot of super tools in it as well, and it lets you go into a separate viewer. And that's on our view menu, 3D view, and there's 2 different ones that I want to talk about. There's the drawing viewer, which prompts you to select things in the drawing to look at.
Right.
There's the surface file viewer that prompts you to pick a surface file, and it loads up the triangles from the surface file. Okay.
Is that orbit in that menu the same as the regular 3D orbit?
That is correct. It is. It says orbit. And now I can do it without having to hold shift and all that. Okay.
Got it.
And I'll go back to my plan view. And now, if I choose this drawing viewer and I select this data and hit enter, it's going to come up into a window that is resizable, repositionable, different things. And you'll see the points are a little heftier, so you can be sure to see them. And you may or may not have You know, it could look like this where somebody, with the last time you used the viewer, you said color by elevation. That's another good indicator of whether your data is distributed correctly. So it should be, you know, the mid levels in green, the high levels are in red, low levels are in blue, and you can change those colors on your settings tab over here. But, you know, so if I knew, let's say I had something over here and somebody had a stray point that was, say, I'm looking at between 1283 to 1347, somewhere in that range. And if I had a point up here that was like at 10,000 feet elevation, you know, busted point, I'm going to see all of this stuff look blue and just that one thing up there looking red. So that's another good indicator. It's a good QA/QC to look at before I even bother to start to make my surface. I'm going to look at those things and I look at these numbers. I see, if I see some numbers that are way outside of my expected range, I know I've got a problem. I can go to my settings tab and turn on my my bounding box. Where, there it is, bounding box. So if I look at that and if I saw that there was a point way up here, that box would be drawn way up high and I would have some little stray something up there causing the box to include it. And all my other data is down there on the bottom. And now I can also, if I say, if I uncheck ignore zero elevations, oh, well, everything I've got has got elevations on it.
Right.
Let me go back out here and I'm going to go to view, restore layers. I'm going to select everything now. And then I'm going to view my drawing viewer. So I'm now going to, now I have everything. Let me turn this bounding box off for right now. And you can see all those blue lines down there.
Yes.
Those are things drawn at zero elevation. You can see what some of those things are. There are all these little symbols and all the road edges. But the road edges also are up here. Now let me turn this color off. Those road edges are also up here in 3D. So they've got them laying right on top of each other. So
there's the flat 2D line work, and then there's separate, the break lines have the actual elevation.
that's correct. So if I had something that was selected that was, you see how that bounding box shows you what else is in there. So again, just a lot of real quick evaluation tools that I could do. So if I had something that was compiled at, say, negative half a foot, it doesn't get ignored because it's not zero, but I'm not aware that it's causing a problem until I look at it with a tool like this and can say, oh, hey, I got a problem here. And I need to figure out what it is to go back and fix it. So I can either leave it spun up like this and go back to settings and hit this little set my AutoCAD view with a current view. And then when I exit, I'm going to come back into it like this, and I'll be able to now go back and find the thing I need to fix, and then come back to my plan view. Okay. So those are all nice tools. And also when I do that, and if I'm looking at all this data, I'll turn this box off for now and ignore zero. So if I'm looking at all this data, I can, right within the same viewer over on this model tab, I can add surfaces. I can freeze different layers. Let's say if I wanted to freeze these major and minor contours, turn off my spots, look at my, turn these spots so I can control the layers. I'm just double clicking these. I can also, I can add a surface, just right click and choose add, or choose this button up here to add a surface. So a surface can come in here and it will overlay this same data. Now, obviously it needs to be in the same location because it doesn't restrict you. I could add a surface from, you know, somewhere over in Podunk, Iowa, and it would be way over you know, wherever those coordinates happen to be.
Right.
So that's all here. Now we're going to get into viewing this and learning how to control the view, which is really quite, you know, once you get used to it, you're going to probably use this even more so than orbit. But by all means, if you're comfortable with orbit and all of that, you can take care of it. But this lets you do things like, if I double click that, it tells me I can change layers. I can set it to 0. I can add it to a selection set. So once I go out of my viewer and I choose to do something that it says select objects, if I type P for previous, it's in that selection set. I've got things like I can clip off my view with these sliders at the bottom, you know, front to back, back to front, top to bottom, bottom to top. I can link these two together. So I sync front and back. So it'll take it from both edges at the same time. Okay. So I can unsync that. You can sync the same thing with top to bottom, but that gives you a lot of information that you don't really get out of orbit. And if you were viewing a surface, you can also save, you can set like view it from the northeast. These are all standard views, or you can save views that you've lined up so you want to always be looking in the right direction. You can take a picture of it, save it to a file. You can save it to a PDF. You can, you know, change the sun shading and all of that kind of stuff.
Yeah.
The other thing is, if you were actually looking at a surface that you've done, so if I go here and I load up a surface, I'm going to go up. Go up a level, go to this last one, and now I've got let's use this one, break lines. That's boundary. Let me see if that's the right one. Yeah. So that was, so that's a surface that gets superimposed over here. I can look at it all at the same time and, you know, verify that things got built correctly, etc. But if I go into this viewer, not like that, but go to my view, 3D view, surface file viewer, and now I take that same surface file. So that's going to come up here, and I can turn on the contours or not. If I not display them, or I can look at the triangle edges and set the colors and all that kind of stuff. But once I've got that done, if I use that version of the viewer where I'm looking at a surface, my pointer here now becomes a 10 editor where I can swap edges, add break lines, remove points, set point elevations, etc. And you go in here and let's say if I wanted to see if I add a break line from here to here. Let's see if I add one from there to there. Well, it's still not able. Let me see if I go from here. Go from here to. There's something about the edge conditions that I'm crossing. I can't fix that one. Let me see. Well, let's remove a point. Let's say if we take this point out, and this point out, and this point out. So you see what I'm doing is I'm getting rid of that ditch, basically, and then here's another You know, so I could make all of those edits right into my 10 editor, and then when I exit, it's going to ask me if I want to save that or not. Now I'm not going to save that because it was an invalid edit, but you know, so that viewer is really, really helpful
Yeah.
once you learn those tools, more so than you get out of 3D orbit.
Yeah.
All right. So that brings us to a good mid-afternoon break point, and let's take. We'll come back about 10 minutes till 3.
Okay.
Then we're gonna really get into modeling the surface with some different techniques, some different things that cause problems, some different things to fix the problems, and how we go about using those tools. And then for tomorrow, we'll get into the actual grading design and all of those tools that allow us to do the design side of this instead of just the basic modeling. All right.
All right. Sounds good, Ken.
Okay, I will stop the share and I will pause the recording. Okay, back all right?
Sure.
Okie doke. So, a couple of things to look at, and we'll, like I said, we're going to learn some tools along the way that we're going to do. So let's take a look at a very common situation where we go to build a surface out of a contour map, because maybe that's all they gave us. All right, so that's fine. But to set this data set up like that, let's turn off the 3D break lines and those points in between. And so we're going to go to our view menu and choose freeze layer by pick. And I'll pick one of those white lines and one of those pink dots, those magenta dots. And then that leaves us with these contours. And if I take a look at it in my 3D viewer, I'm going to verify that, and that's all that I have. I do have these blocks that are set as, that they put in as labeled spot elevations. So sometimes we may have those, and so we'll use that. We'll go ahead and use that, but we don't have all of those other points in between these contours. So we don't get the nuances in between here. We only get straight line triangles between contour lines, okay? Everything else, even though we see it, is down at 0. We verified that by looking at our 3D viewer, our drawing viewer, and we don't see anything else there other than these contours and those spots, okay? So that's often what we have to work with, and then we'll show you some of the things that come about with this process. Another quick something I want to show you real quick. I'm gonna take a real quick aside. There's a tool, it's in the book under the file menu commands called Drawing Cleanup. If you take a look at that, this is a really handy, really useful tool, and it's easy to forget about. But you see all of these different things that you can do. You can set the coordinate system to world. You can convert it from an architectural unit drawing into decimal formats. Now you can do all that stuff with standard CAD commands as well. But you can reduce, get rid of duplicate line work. That's the overkill command. Remove overlapping polyline loops. So if you're dealing with contours that shouldn't overlap, it will put little gaps in them where they overlap each other if they happen to do that. You can join line work with same endpoint. So if all the contours are drawn as little bitty individual segments, you can have it join those together. You got to be careful. Sometimes it goes to the wrong line. You got to look at that. But I'm going to clear, get rid of everything here and show you a really good elevation checker for your data other than that 3D viewer. That part's good too. But you can also do this. if you set the elevations outside a given range to 0, and if you happen to know, well, I'm at about elevation 1300 here, you could say, 1100 to 1400 and do all that. Or when you first turn this on, there's a button here that says scan drawing. So if you scan the drawing, it's going to look at everything in the drawing and show you the minimum and maximum elevations right down here. So if you do that and you happen to come in here and this says negative 40,000, well, you got a problem. Or if this is something setting up at say 15,000, you know that you're outside of your expected range. Or even if it's just like -1, or if it's 1, 2, or 3 or something that is nowhere near your elevations, then you can, once you've scanned the drawing and see what's in it, you can then type in new numbers here. I could say 1200 to 50. Anything outside of that range, I'm telling it to set the elevation to 0. So it doesn't get rid of the object, it just sets its elevation to 0.
So like maybe somewhere in the drawing, there's a road polyline and someone accidentally set an elevation to it when they didn't mean to. Instead of bringing that in and having it potentially throw off your surface generation, it just ignores it. But it still brings the line in, but it ignores that elevation.
Well, yeah, or you can, because it's set to 0, and then you can go and find that by looking at things that are just at 0. And if you need to make some edits to it, you can put it at its proper elevation. So either way.
Got it.
So it takes it out, but it leaves it in the drawing. So you're not getting rid of data. You're basically getting rid of the bad data. So any of those elevations that are outside that range, it sets it down to 0.
Yeah.
And so that's a nice little thing, and it can work on the entire drawing or only on a selection set. So it's a nice little QA/QC tool that you can use, and it will take care of doing a lot of the cleanup that you normally have to do manually. So don't lose track of that tool. It's on the file menu, drawing cleanup. Okay. Now, so what we have are some things at elevation, and we know, okay, we're going to, we want to now do to build a surface. Okay, and oh, before we do that, you asked me earlier about these toolbars. Let me show you the ones that I've got, and you can, use them if you want or whatever, but there's several ways of looking for them. If you right click and choose AutoCAD, those are the AutoCAD toolbars that I have out.
Mhm.
These are the Carlson toolbars that I have out. Okay. Or you can also go to the settings menu and choose toolbar manager. So you can save and load different configurations. There's also well, it's not in this. In the IntelliCAD version, there's a way that just brings up a pick list of all of those, the same as doing this. Okay, so let me get this out of the way a little bit here. There we go. So you can see the ones that I have. I've got Carlson menus, and that's this one up here, the lower one on the far left.
Yep.
That's my menus. And I've got the Carlson draw commands because that lets me have access to the Carlson draw tools, one of which is this shrink wrap entities and revision clouds and all that kind of stuff. And it doesn't matter which ones you use, but I find the Carlson tools gives me a bit more control over certain things. But I also keep the AutoCAD tools out there too, because sometimes you just want to draw a circle,
Right.
And then the different, I've got edit, elevate. I've got this Carlson layers. Now I've also got AutoCAD layers. I've got layers two, which is, let's see what it does. Match, change to current, isolate, unisolate. There's layer walk, freeze by touching, layer off and on. Those are kind of things that I'm just so used to using them from the Carlson toolbar that I do them from there, and I just keep that out of my way. It's entirely up to you as to which ones you want to use. And the AutoCAD layers toolbar is this one where it lets me get to my layers manager.
Yeah.
And that little pull down, and I've got current, previous, and layer states. And that's all I have on there. I don't have the isolate and restore. You can do it from that, and that's the layers too. But I have these on, and my elevate commands are on a toolbar that you find mostly under the 3D data menu, like set polyline to elevation, 2D to 3D by these different methods. That's our draping. You know, so different commands are different places. One that I find very, very useful is this one called polylines. And the reason that I have that, I also keep my surface up there. And let's see, was there? Yeah, my surface menu. There's another one, my 3D views. Let's see if I've got it. Actually, it's included on the surface toolbar. So that's there. But this polyline toolbar is this one right here that it has these commands like extend by distance, boundary polyline, which doesn't do what it sounds like. It sounds like it draws a boundary, but it's not from the outside in, it's from the inside out. It's basically creates the boundary of a hatch region. So if you're on the inside of a bunch of overlapping lines and click a point, it will find the boundary that encloses that point.
I see.
That's a standard thing. Now on the draw menu, you see it's right here called boundary polyline, but what we are going to be using is this shrink wrap, and that's where we go from the outside in and we create our boundary that goes around our data. Okay. So
because it's not surface right now and we can't generate the boundary from the surface.
Yeah, well, I mean, we can draw the shrink wrap anytime we want around any kind of data. And let's just say we did that. You know, there's the fence that around now. It didn't close in here because of a setting that I had. There's a stray point out here. I'm going to delete that. And I'm going to select that point, or actually it's a little bitty polyline, and it's stray. It's not part of our data. So I'm going to take that out. But then if I, you know, I can draw that boundary, and let's put this to a little medium reduction. And we'll talk about this in a little more detail when we get back to it, but that generates, you know, it tightens in and goes to the outside. I can use that as my enclosing boundary for my surface if I so choose.
What did you set your perimeter reduction to?
Medium.
Medium.
Yeah, we'll talk about that in a minute when we get to it.
Okay.
But for now, I'm going to just leave it off, and we're going to go to the main tool for creating a surface, which is on our surface menu. It's called Triangulate and Contour. Now, here's where you can set some boundaries and all that kind of stuff. But if we do this main command, this is the workhorse of the terrain modeling. And I've got 4 tabs across the top. And one of the things you can do with this selection, and I would recommend you always take a peek at that to make sure you haven't specified, you know, filtered certain things. Like if I don't want to use any 2D polylines or any Carlson points, I can turn them off. Okay. But if I just uncheck those and leave it blank, that means it's going to take anything I select and it's going to look at it as a possible part of my surface.
Right.
Okay. And then I've got my triangulation, which controls how the triangulation is formed. And then I've got contouring and labeling. And a lot of people do that all in one step and they go, oh, great, I got a surface, I'm done. I like to leave this off when I'm first doing stuff and evaluate what happens until I'm ready to go, because I can draw these contours at any point after the fact. But it's there if you want it. And that's why it's called triangulating contour. Now it's on a toolbar button, this one right here. The button is called surface. And there is the triangulating contour command. It's also on the surface menu. But now I was starting to tell you about this polyline toolbar, why it's so useful is because of these commands right in here. This remove polyline segment, remove polyline vertex, add the polyline vertex, close, densify if you want, or reduce if you want. This one here, join nearest. Now those are all commands that are scattered throughout. Like if I look under edit, there's join nearest. And I've got extend by distance. So you can see the icon gives you an idea of what it does. Now here's another little helpful hint. When you look at these menu commands, like erase, the only ones that have icons to the left of them are the ones that also exist on some toolbar somewhere. It doesn't tell you which toolbar it's on, but that at least tells you that it's available. Like this erase by layer is actually on the layers toolbar, and it's over right here. And it's a really, really useful toolbar command, or useful command. It lets you pick things on a given set of layers and erase everything on those layers. And you can even limit the things that you want to get rid of, like hatches, multi-lines and ellipses, or everything on those layers. You can pick them from the screen, you can pick them by a name, all kinds of stuff. And that list stays there from the last time you used it per editing session. It doesn't stay between open and closes. But so it's really helpful, like if you're designing building pads and you're tweaking stuff and you're going around, it will take care of letting you go through and erase all the stuff you've drawn, throw it away, go back and try it again. If you need to erase it again, you don't have to go back to picking all those things again. It's already sitting there waiting for you.
Got it.
So, but now these particular remove polyline vertex and segment and add polyline vertex, do this real quick. Just draw a little 2D polyline anywhere and, you know, do the old Homer Simpson hairline or Charlie Brown sweater, whatever you want to call it. Now, let's suppose that we had an instance where we wanted to we had a polyline that had a bunch of points in it, and we wanted to get rid of these points out of this polyline. So how do you normally do that?
Select the polyline, select the vertex, or hover the vertex and remove.
Okay, yeah, you can do that and remove the vertex and remove the vertex. And that's fine. I do that quite a bit sometimes if it's something that's straightforward.
Yeah.
But if it's you know, if there's like tons and tons of those things in there, let's say let's jump down here and say choose that one. All right, so now instead of having to go erase and erase and erase and hover every time, if we normally did that with, say, the p-edit command, so what do we have to do? We have to say edit vertex. There's nothing there that says remove a vertex, so I have to edit the vertex. It marks me where I am. I have to go up next, next, next. And now to delete that one, I have to know that that's a straighten command.
Right.
So I go straighten, all right. I go next, next, I type G to go.
Yep.
And then I go next again, next, straighten, then next, 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 and go.
Right.
All right, so that gets a little tedious after a while.
Yeah.
So Carlson has this really nice, well thought out tool. Let me get out of all that. set this back. And here's why I like it on the toolbar, because I know right where it is, because otherwise it's under edit, polyline utilities, remove polyline vertex. All right, so it just says you pick the polyline and it put little blips on there for you. And then you just click near that point, and it's the nearest point that you, whoops, let me undo. Yeah, let's try that again. Put two near the other one. And so, so now I'm just going to pick nearer to that point, nearer to that point, nearer to that point. And I can skip all around. I don't have to next, go, straighten, all that kind of mess. It lets me do it that way.
Got it.
Can do the same thing with this, say, add a polyline vertex. I can click here and I can go to, you know, the center of that circle. And I can pick and pick over here, pick back over here. So, you know, same thing is if I want to remove that segment, well, I just pick that segment and it's gone. I don't have to break and do all that kind of stuff. All right. So that's why I like that particular toolbar, because it's got a command or a set of commands, those polyline commands that are buried pretty deep under the edit menu, under polyline utilities, remove, which doesn't mean erase the polyline. It means those are remove functions. And there's those two little icons there on the toolbar up there. And you can check the elevation ranges. You know, there's all kinds of things that are out here. That there's reduce and densify. That's also up here as well. So it's just really handy to have. All right. So with that now, and you'll develop your own stable of tools that you like to use. So but those are the ones that I have. Now, back to our triangulate and contour. We're going to build our surface, and I'm going to go to contour tab and I'm going to uncheck draw contours. I'll look at my selection tab and see there's nothing's checked to filter, so I'm good to go there. My labels tab is completely grayed out because I'm not drawing them. Okay, so I don't have to do anything with that one. Let's go here. Now, once here, you've got some controls at the top. You can draw the triangulation lines if you want to draw them into the drawing, you'll see them. Or you can draw them as 3D faces. And again, I don't have any need to do that because I can see those in my surface viewer once I'm done. Or I can draw them at any point later with this draw surface, draw triangular mesh. And that gives me that same option, okay? So here's my first step is I'm gonna not draw, but I will triangulate. And I'm not going to draw any of these things, but I will write the file. I want to write this triangulation file. Otherwise, it just builds it and it keeps it available in this session and it's gone after the fact.
Right.
Turn that on and I'm going to choose select. I'm going to give it a name and I'm just going to call this one EG dash contours only. And I'm going to also switch to my right, to my proper folder I was in last session. There we go. So EG, now, when you look at your data, when you pull this thing down, I forgot to tell you this. If you see any of these files that have periods in front of them, period, underscore, those are files. I don't know that you have them or not. They may be in there, but you can ignore those files. Those are just little resource files that came from the fact that I did this on a Macintosh.
Okay.
So if you had those, you can just erase them or ignore them, either one, it doesn't matter. They're very tiny files, just 4K. So anyway, I'm gonna call this EG contours only. I'll hit save. And let's see, I'm still in this wrong. There we go. Now if I save. So that's going to be called EG existing grade contours only. And if I have a drawn boundary already sitting here waiting on me, I would say use the inclusion exclusion area. And then I would tell it to either remove the entire triangle that might cross it or trim the triangles at the boundary, which is what I usually want to do. But if I don't have it, it allows me now to have it do this for me automatically. And I would say, okay, I'm going to let it do the shrink wrap. And this is the amount of perimeter reduction. And we're going to set this to none right now and leave it alone. We'll talk about that in the next couple of passes here.
Okay.
What that means. And it's sort of odd, and this is more programmer speak than user speak.
Mhm.
And erasing previous contour entities, you can turn it off or all. So a lot of times if you're doing this over and over again, you want to get rid of any contours, anything that came out of that surface generation. You'll have it erase it and reconstruct it.
Right.
If you say all, it's going to be everything from every surface you've built. But if you say current surface, it will only work on the one that you have currently involved up here. So I'll leave that to current surface right now. I'm going to, again, by default, back in my general settings, I had ignore 0. That's why that's checked. I can limit it to certain elevation ranges. I can, highlight break lines, etc. Put them on layers with the surface name, all that kind of stuff. I can set the maximum length of triangles I want to consider. So that's another way of getting rid of some of these out here. You can give it a large enough value. Also for interior, like if you had a big pond in the middle and you didn't want to go across the pond, you could do that. I would just, put those at a couple 1,000 feet, and we don't really use them much. And right here is where I told you, like those parking lots where I showed you where I identified those points. But now this lets you automatically densify everything you correct. So if you get a line that only has endpoint elevations, you say densify the break line, it's going to drop points every whatever number distance along those lines to use as triangles. If you don't do this, it only uses those endpoints, the places where it has actual vertices. Okay, so you can turn that on and off. Now, this next box down here, adjustments for source data of contours. So if we're reading contours, which we are, we're using these contour lines as our data, we can tell it to interpolate ridges and valleys. So it's going to try to figure out when it sees a set of data that looks like it should be a valley or a ridge, it's going to try to interpolate that, interpolate summits and pits. Well, and this not only does it try to recognize that, but it also tries to go down and find the very bottom, even though, it's not, the bottom can be a little bit below the bottom of that contour elevation. Same thing for summits and pits. If you've got a series of concentric contours that go up, if they stop at a particular one and doesn't go all the way up to a peak, if you turn that on, it will go all the way up to the peak.
Mhm.
Otherwise, it's not. So if you're out in Arizona and you got a bunch of mesas, you don't want to turn that on. Okay. Now,
Right.
this one is the big one that minimizes flat triangles, and that's the one that takes care of as best it can. It tries to find in areas that have these nose-shaped contours where flat contours occur, or where flat triangles could occur. It will try to minimize that. It's far from foolproof, but that's a switch there. But for right now, let's leave everything off. And I'm not going to simplify the surface. This is not that large a site, so I'm not going to throw out any data. And so I'll let you get everything set up like that. And I'm going to say, okay. And I'm going to follow the prompts. Now it says select objects, but read the line above it. It says select the points and break lines you want to triangulate. You can either draw a window around it, or you can type the word ALL, hit enter. It still asks to select object. You're done, hit enter. it comes back and tells you that, all right, inserted so many points, inserted so many break line segments, and it wrote that file, e.g. CTRS only, okay? Now, this is the point where a lot of training companies will say, congratulations, you just made your surface file go on about your business. Well, that's well and good, but let's take a look at it and see what happened. So if I go to my view menu and my 3D view, and I look at my surface file viewer, and I look at that e.g. contours only, let's make sure I need to set that as my current folder. There we go. I think that will set it. There, now it's set. All right, so now this is just a list of recent files. So if I look at that, here's my EG contours only. I'll say open. So up it's going to come into my viewer, and let's go to my settings. I'll turn off my triangle edges, go back to my view control, and I see over in here those long skinny triangles I've got. But look what happened along this road edge. Now we know just from experience that road doesn't do that. Right. And those are those flat triangles that formed. And I also had something way up here I want to show you about right in here that looks like a little ski jump or a skateboard ramp or something that formed in here. Now, when I look at that in my data set, that doesn't exist. And what happened was this. That's right in here along this structure here. So I had all these contour lines. It came in like this, and then these come up here and just sort of stop. Well, that's because this is a retaining wall, but we turned off the break line, so we didn't have it. Remember, this is just the zero elevation outline of that retaining wall.
Right.
So that's why it jumped from these in here, it shot way out here and hit these and built triangles instead of seeing that wall and stopping.
Yeah.
So that's an instance of where you got a problem that we need to figure out how to fix. Now, you know, this particular data set, we have the original data, we have the break lines, so that's going to give us our best bet. But how do we go about fixing some of those problems, and how do we go about visualizing them? And if I look at, say, these, let's isolate just the contours. So I'm going to go back to, I'll go to my layers toolbar or my view menu, and I'm going to say isolate layers, and I'm going to choose one of the major contours, one of the minors, and I'm going to also come in here and get these major and minor broken contours because it does an area called obscured. So there's now my data that I'm using to build this surface with. It looks pretty good in terms of contours, but you know, and I look down here, I look at the road, and I know inherently that's a gutter line, but you saw all those jumbledy blocks, all those flat triangles, and up in here is where you saw that little ski jump.
Yeah.
Okay, now while we're in here, let me show you a couple of techniques about how to set your view. When you look at these controls in here, and yours are going to be slightly different. You've got might be the hand for panning that lets you pan things around. But this one right here is the rotation mode cursor. That's the one you want. And it looks like in your case, the XY, the old UCS icon, and a curved Z arrow.
Yeah.
something like that. So that's the one you want to do. Now, what happens is when you choose that and then you put the cursor over the data, when you're on the edges, and it doesn't cut off exactly at the edge, but when you're on the edges, you see it's the Z, it says Z and shows you rotation. But when you move into the middle, it switches to X and Y.
Yeah.
Okay, so here's how we control where we want to be looking. If you imagine when you're looking at this, that you are standing in your driveway and you're looking at your garage door, and you have one of those solid doors that's not got segments in it. And when you raise it up, it's going to just raise up and go up flat into the sky. So we're going to make sure that over here on our rotation axis buttons, we're going to lock that Y axis and just leave that locked.
Yep.
Okay, so now when we move this around, even if we go back and forth, nothing happens. But if we go up and down, it's going to lay it back or pull it down. So you're going to go down toward the bottom, but not so much that it becomes a Z. You're going to just grab X, Y, and you're going to click and hold the mouse, and you're going to push it up. Go grab another bite if you need to. And you're going to lay it back at a fairly oblique angle, about like that. And then put the cursor down at the bottom to when it turns into a Z axis, and then go back and forth only so you're spinning it around. Okay, and I'm going to hit this lower right to go to my plan view icon. I'll switch back to my control. Now let's say I wanted to look, I want to look down this roadway right-hand edge and sort of eyeball down that edge. So I'm going to position this up. I'm going to lay it back flat like this. And then I'm going to scroll it around to where now I'm lined up. And then I'm just going to point to it and use the wheel to roll in and out. Okay. Now, if I need to change my view, let's say I wanted to look at that little pond over there. Well, I can either, pull it back down or go back to plan view. Pull this up like this, spin it around, maybe slow it up a little bit there, and now go and look at this little pond right here. Okay. And then, the wheel, and you can press and hold the wheel to pan. You can zoom in and out to pan. So just zooming back, resetting your point of view, and then you're pretty well good to go on figuring out how to look at this from any given perspective. But the key is to keep this Y-axis locked and to understand when you're in the middle, it's X, Y, so that rolls it up and down. When you're on the edges, that rolls it back and forth around the Z. Okay. And so once we've checked that out, we've seen some things, we'll exit. Now let's go and fix a couple of things that we have, or we'll take a look at some things first. Let's look at the profile menu, and we'll do a quick profile. And let's choose the surface file as our source. And if you have names in here, especially if you have something in the second one, you want to click that and choose cancel so it clears. But look at the first and then set that surface, e.g. contours only. We'll say okay. And now it's going to prompt you to pick a starting point or choose a centerline file or a drawn polyline. Well, I want to look from here. I'm going to come down this edge here like to right in here. Okay. And I could keep going and all that, but I'm done. I'll just hit enter. And now I get the split view and I see the line that I picked up here. Now I can't interact with it other than to zoom in and out. But when I come down here, I get a little marker that shows me walking down this contour line. So when I look at it right in here, and again, I can set, no exaggeration, fit, 2 times, 5 times, all that. So if I look in here, right in there, and I want to zoom in up here. So I'm going to click up here, zoom this around. And now when I come back down here, see right in there in my profile, it shows as flat.
Yes.
And then it drops and then it goes flat again right in here. Drops and goes flat again right in there.
Yep.
That's because when it built this, it came around here and it set between these two contours and built triangles. That was fine. But when it got here, it looked across here and started building these triangles across here that made those flat. They're all at the same elevation.
Yep.
So to be able to fix that, of course, I need to put in that break line and establish them at the elevation. Now, there's several ways of doing that. And again, we have the original, so we're not going to spend a whole lot of time, but when you have to add break lines, here's how you do that. You're going to either draw a 3D polyline, and you can have it prompt for the elevation, the slope if you want or not. Let's say if I don't, and I say okay, and I'm put right on that endpoint and that endpoint. I'm going to come down, I'm just going to walk down this edge, and you're going to see what happens in a certain situation. Why there's a slightly better way of doing this in a minute. And I'm going to keep coming here and here and here. Trying to get to a place where I'm not going to see it on this one. All right. That one's okay. So now when I did that, and I hover, I see that that's actually read the elevations of those contours. So that part's okay. But what happens if I do this? I'm going to draw a 3D polyline on the other side now. And I'll just start in here, I'm going to here, to here, to here, here, and here, and here. Now, look what happened when we change these colors. So you can tell what the break lines are. So what happened in here is if it doesn't show it very well. Let me see what layer that is. V topo minor. And let's give it a see. All right. So what did that not take? Oh, I did the wrong. All right, so here's my majors, here's my minors. So what happens in here, I go, okay, but I'm getting awfully close to that. And I even come into a situation here where I cross. Yeah, right in here. So I'm saying go from here at this elevation down to this elevation, but in so doing, I'm crossing that same elevation here again. So I needed to have done something like this. I should have gone out here and put some things out here in the middle. But what happens there is that these elevations, these vertices have 0 elevation. So if I look at all of this stuff in my 3D viewer, see that? So that would be a problem. I would need to interpolate that. So I could do that in this fashion. I could say, draw a 3D polyline, and I would turn on prompt for elevation slope.
Right.
When I do that, and I go here, it reads that elevation. If I'm good with it, I just hit enter. I'm now going to pick out in here, and it wants to know the elevation. It tells me the line above that it's 0, but I can say interpolate, I.
Yep.
Now it's going to interpolate until I get to that elevation. It reads it as 1294. I'll now select it. And now when I look at it, you'll see pick the wrong one. Oh, there, yeah. So now it's this little green one in the middle.
Yep.
So now when I look at it, I can see that it went around the curve, but it didn't use those zeros. So I could have interpolated that correctly. All right. So that's okay, but that still gets a bit tedious. And here is the approved solution on how to do that kind of stuff. Draw first a 2D polyline. And I'm going to put that on a layer here called break line. And you can snap to these things if you want to. Whoops. Let me get on down in here where we crossed. All right, so now I've done that and I've crossed, but I can easily add a polyline vertex. I'll pick this here and I'll say maybe I'll put one out here and one out here. Or I could do it another way you might be used to seeing it is right click, hover, convert to arc.
Yep.
And you can pull it out like that so you can, you know, sort of modify your way around here. Let's see. Keep snapping. There we go. You know, so you would line it in there and fit it up, you know, the best way you need, scoot out points as you need to do it. But now it's still a 2D polyline. To be able to use it as a break line, though, we need to drape that onto something with elevations. And that's on our 3D data menu. And we're going to say 2D to 3D. And in this case, we're going to use screen entities, those drawn contour lines or anything else that has elevation. So when we do that, we're going to say, we'll give it a little tolerance of a 10th. Ignore zeros if you want. Let's do that. Interpolate the end elevation. So if it went out here and stopped, you would just push it out at the last slope and stop. And I'm going to uncheck keep the existing. And I'm not going to change the layer name. So I'm just going to ignore zeros, extrapolate endpoints, even though I ended on one, and I'll say OK. So now select the polylines you want to convert. Well, it's just that one. Now select other things that you want to use. I'll just do a crossing selection. And it said now it converted. I'll verify that again with my viewer. Now see that, yes, indeed, I now have a break line that would control that edge. And if I go back to triangulate and contour, and I'm going to say, well, actually, before I do that, I'm going to do another break line. I'll draw a 2D break line or 2D polyline. I'll come over here and fix that ski jump. So I'm going to go from here picking up all of these. And let's see, I'll bring that back to somewhere in here, so I'm keeping it done. And I'll do that same command, 2D to 3D by screen entities. I'll use that one, and I will then select all of these to use. It's now elevated. I verify that with my viewer. Say, yep, that does what I wanted it to do. And now that's going to be a sloping wall. I could have offset this up and put a top of wall in here. I right now have the bottom and the top and the back side. So you'll see the difference though. So when
So if you had done that though, so when you created this line, you created it as a 2D poly, right?
Yep.
And then you draped it onto the surface so that it pulled whatever the elevation data associated with the vertices are.
Yeah.
But if you had wanted to create the top of wall, wouldn't that involve creating a 3D polyline?
Yeah, but what you would do is you would take that line, now that it is a 3D polyline, and you would offset it with a 3D offset.
Okay.
I forget what that's called in Civil 3D. It's called a step or something like that.
Stepped offset.
Yeah. So that you would set it back just slightly to put the top in, and you'd have to know some height information. I don't know what that height is off the top of my head.
Gotcha.
Again, they've compiled it, so I've got the data originally. In fact, one of the things that I could do, in fact, I'm going to go ahead and erase this, and I'm going to turn all my layers back on, and I'm going to use that. That's let me freeze the break line layer, which is this one, and those points. And so here's my 2D of that wall outline. So if I wanted to if I had it in 2D already drawn, I want to elevate that by screen entities, and I'm going to keep the existing, and I'm going to put this on the layer that I make a break line. So I'll select this. Now select the things that I want to use. Anywhere it touches those, it will set that elevation. And so now, if I isolate my contours and that one, and let me get these contours. So I'm back to where I was. Now, if I look at that in my viewer, you can see how they've got that done there as well. Okay. But again, it's the bottom and it goes all the way back to the back. So I would normally put the top in if I knew that top elevation. I may not know it. So now back to building that surface, I'm going to call this one, write the triangulation file, select it, and I'm going to call this one EG. Well, break lines. Oh, actually, I wanted to call it contours and break lines. So I'll say, okay, I'll select all my objects. It builds a surface. I look at that surface now, and you're going to be able to see right down here.
It smoothed that stuff out.
Yeah, I smoothed out the stair steps in the road a little bit. I still got some things I need to tweak in there, but that ski jump that was back here is now gone. And I can do another thing in my model tab. I can add a surface to this Back to my view control, I'm going to turn off the fill in, turn it back on so I don't get that garish red. And now you can see how the original surface is that brown one. The one that I modified is the pink one. Go back to this, open this up. I can turn this one on and off, or I can hide that, show it, hide that one, show it. So that gives you a way to evaluate things. Now, since we have two surfaces, if we go back to that profile menu and do another quick profile, again, we'll use surface files, and this time we're going to use for the first, we'll use our contours only. For our second, we'll use our contours and break lines. And now we choose OK, and let's just look at it, say from here across here, and be done. And now you can see that ski jump is in that original, that's in that first surface. That's what's tracking in terms of over here, it's reading off, you know, the elevations and such. But you see the red line is that second surface. That's the one where that was taken out of it. So you can tell the difference. Same thing is if we come back in, we say adjust the alignment. So I'm going to put this, say, here. I'll adjust this corner up to here. So now you can see I'm looking down that road edge, and you can see the difference. You see the stair steps versus the smoothness. And you see the places where I still need to figure out a couple of things. But so those are some of the tools that you're going to be able to use to add some intelligence into the surface.
Yeah. So could you, would you mind stepping back through the draping of the 2D polylines onto the surface? Because I'm having some issues recreating that.
Yeah, sure. I'm going to take this and actually just delete it.
Okay.
And let's go across this pond here for a minute. I'm going to draw a 2D polyline. And I'm just going to draw a 2D polyline across here. Okay. Now, when we convert this from a 2D polyline to a 3D polyline, we have these methods. If you know the start and the end elevation, it will do that and interpolate all along in the middle. It can do it by text. It can do it by points. It can do it by a surface model. So if I've already modeled a surface and I want to drape it on that surface, that's what I would do. For instance, if I'm going to put a sewer line or a water line in, if I'm going to put a water line in 4 feet below the ground, I may drape it on a surface model and then drop it by 4 feet after I draped it so that it's now 4 feet below the ground. Okay. So any of these methods will work. I'm going to use screen entities. That means things that are drawn in the drawing.
Yes.
So when I choose that, I've got this intersection extend. That means if it's close within this tolerance, go ahead and consider it intersecting, even if it doesn't. So it reads it, or you can set it to 0. Let's see.
Okay, so when I click the 2D to 3D polyline and select by screen entity, this menu does not pop up for me.
Oh, okay. Do you have an O for options on your command line?
No, as soon as I click the 2D to 3D polyline and then select screen entity, it just, the only thing the command line says is select, it tells me to select the objects.
Oh, okay. So it will probably ask you some of this other stuff at the conclusion of that. So that's a difference they've made in version. So
Okay.
if I say, so I'm not going to change those. I'm going to say, okay, so now it's wanting me to select the ones I want to change is this one. any others. I'll hit enter, and now it says select the surface 3D faces, lines, and polylines, correct?
I was missing that part. I see.
All right, so now you select the things you want to use, and I'm just going to drag across to where I get everything that's being considered, but it only looks within 1/10 of a foot to see whether it hits it, okay? So all of this other stuff it will ignore.
Yeah.
I'll say enter, and now it's done it for me, but it should now at this point ask you if you want to change layers or keep the original.
Yes.
Okay, so that's just basically they've put those questions up in a dialogue up front. And so now, if I look at that part in 3D, in my 3D viewer, I can see that, wow, look at there, it draped it right across those. Now, when it drapes it across those, keep in mind, it only goes just like building a surface from contours. Like there might actually be a little localized depression right in here, but it has no way of knowing that. It only goes from this point to this point to this point to this point, okay? But that's one way that you can add break lines into data if you don't have it to control, you know, what you're modifying, okay? So now, that being said and figured out and understood why it's important, we had the option, we had the luxury of them having built. So I'm going to turn on all my layers. I'm going to go here to view, thaw, on all layers. I've got data that they use to build their contours with. And I'm going to change that color back. It was 93, maybe something like that. Really not much of a difference. Turn on time here, minor. Let's make it. All right, that's a little bit better. All right, so because I have, let's see what I've got. Wait, where's my? Oh, there it is. All right, so I've turned my line weights on. I don't have specific line weights. I thought maybe these were heavier, but anyway. So now that I've got that data I can use, here's another thing to be wary of. If you do this same thing, triangulate and contour, and let's make another file now. And we're going to call this one EG-CTRS- all breaks, we'll call it. And we'll say okay. And we'll select all of our data. Now watch what happens. I get this little error box that pops up.
Yep.
Okay, so it built it, but I've got some problems. And there are 3 types of problems. I've got crossing break lines with T intersections, and vertical edges. And really T intersections and crossings are the same thing. It's just that it doesn't go on a cross. It just ends at a T intersection. Now, in my settings here, I put in a particular value that if it's close enough within, say, 1/100th of a foot, I may change that to 0.01 instead of like that. But right now, this is all, you know, it's going to find any of these particular problems. Okay. And if I look at, let's just look at these, well, let's look first at this T intersection. It tells me I have 1. If I open that up, I see that, and the number in parentheses tells me how much difference there is in vertical elevation right there. Now, it went ahead and built the surface file and it chose one of those. I don't know which one it chose, but it tells me, hey, here's a problem. So I see that it's 4.5 feet difference in elevation. I get a little marker over here in my plan view. Now I can click over there and zoom in and out and click on it again to get my marker back. And I see right in there, I've got a T intersecting line and I can tell what it is. I can zoom in and it keeps the marker on. So it's where this contour line runs up here and dead ends into this 3D line. And it's 4.5 feet different right there. Well, I need to resolve that. And you can do it several ways. You can, spin this thing up a little bit and see if I can get and keep it where I was right in here. And I see right there's that difference. It crosses here, okay, it didn't flag a problem. So I could just simply pull this thing back to here and that would eliminate that one error. Okay. So I had a drawn contour line in there that shouldn't have been. That's probably another one of those little retaining wall situations. Okay. And then when they compiled the contours, they cross here and shouldn't have, or they hit up into the edge of it and shouldn't have. So, that would have fixed that one. Now this doesn't go away until I rebuild the surface. I got the same thing with some vertical edges. Here's one that's pretty close. I'll zoom to that. Let me go back to plan view. I'll click this again, see where it is, zoom to, zoom in. So right in here, I've got a vertical edge. It looks like probably the 3D break line for the curb edge is above the one that they brought down here for the road edge. So I can either trim one of those back or put a little gap in it, do something. So I think what I'll do is simply, I'll just simply pull this guy back a little bit. Right in there, make sure I didn't. Whoops, I set that at 0 elevation. So let me, instead, I'll just delete that polyline vertex. All right, so that pulled that back to there. It doesn't come all the way around. So that will eliminate that one. So you work your way around it. But now look at this, and this is what I really was getting into. See all these crossing break lines?
Yes.
Look at what they are. It's where a contour line comes in and crosses the 3D compilation, the 3D break lines. Now, what that tells me is that when they drew their contour lines, they probably had some kind of algorithm on that read everything and then drew it and then sort of snugged up the edges. And they may have edited them, or they may have just, they're working within their own tolerance values. And so they're not, here's a contour line that comes up and crosses here and comes back out. So I've got all these crossings. And remember, though, that the contours are the output of that modeling. So instead of using all of those 3D edges and points and the contours, let's freeze the contours that they drew. So I'm going to freeze by pick, and I'm going to zoom in here. I'm going to freeze one of those obscured major, obscured minor, my normal major, my normal minor. And now I've turned off the contour lines that cross, and I'm only left with this data. That really is all they used to define that surface. Okay. So now when I triangulate and contour again, new file, this is going to be called EG-break line only. I'll say okay. Select all my data, hit enter. I'm still going to get some problems, but I don't have 542 of them. I've still got some things where, and here's like 3/10 of a foot. And I zoom down here and I see it's all around this head wall. Well, instead of stepping you through fixing all of that kind of stuff, I'll show you over here that I think I can go into my viewer with that open. I think so. Let's see. Yep. So that's a head wall. But if I zoom this thing up, I can see, well, they got in a hurry when they compiled that and they missed it. They're along the top here and on the bottom here, but they crossed it and they didn't get it all. So that's an error on the originator's part. See, this is a separate line that was the bottom edge maybe, or the top edge, whichever.
Right.
See, and so, you know, we could either fix that ourselves if we knew what it was, or ask them to fix it, or live with it. Right now, we're just going to live with it. I've got a vertical edge here. It's just 100th. And it's right there where one thing went up and joined the edge of this little sidewalk or curb or whatever. And so I might simply move this back. I'm going to just snap it. Right in there. So that take care of that. I'll exit. I'll go back. I'm going to re-triangulate and contour. Keep the file name the same. I'll say okay. Yes, it's okay to overwrite. Select my data. And now I've only got that head wall situation, which I would have resolved if I were doing this for real. That vertical edge is now fixed. And so now we have this surface that is much more defined with these break lines, at which point I could then draw my contours. And we use break lines only. And it's going to bring up the same box except for the triangulate tab. I don't need to worry about anything here like using inclusion, exclusion. I'll just say contour, draw the contours every 1 foot, draw the index contours 5 feet. I'm not going to label them. I'll just draw that. And so now those are the contour lines. And if I turn their contour lines back on, just turn everything on, you can see that, you know, there's a couple of places that's a little bit of difference, but for the most part, they're exactly where their contours were. And if I freeze the break lines and get some of that confusion out. So you see my contours are the white ones. Theirs are the green ones. So there's a couple of little nuanced differences that if you notice any big discrepancies, you could fix it. But look at your contours down the road edges. You followed their contours exactly. So right in there's a little difference. I don't remember. I may have. Oh, I said reduce, and I had Bezier smoothing on. Okay, so now if I turn my smoothing off, oh, I need to one more time, and I need to change that. See if it does it. There we go. So it redraws. So now I turn my smoothing off, and so they may have had their smoothing on. They have, there's some other little something that their contour had this point in it that mine doesn't have. So, you know, those are really trivial in the way they fit. So yours fit, you know, ours from their data look very close to what theirs are. So I would call that, a decent enough job. But here you can see that wall. And if we look at that in our viewer, our surface viewer, right there's that wall. You see these other walls up here in the back, right in here. There's that one where that contour came up and crossed it with a T intersection. So it modeled all that. You see our curbs are modeled. And down the road edges, all of those stair steps are gone. They're coming right down the edge of that road. Now we also have a bunch of triangles out here that we don't need. So we would limit that with going back to this. Let me erase by layer. Select layers from the screen. I'll get my drawn contours. I'm going to freeze their contours. And now I'm going to put on I'm actually going to take, they've got some points out here, these 2 points on this edge. I'm going to get rid of those. So now I'm going to either, you can do two things. You can just draw your own boundary, draw a polyline and use it as a boundary. Or you can use that shrink wrap where you can do it manually. We're going to go through this manually, or then we're going to also just let it do it in the command. So if I choose on the draw menu, shrink wrap entities, you have some choices: across gaps or use bounded line work only. Now, let me show you an example of that real quick. I'm going to cancel that. I'm going to go over here and draw some polylines. Let's see. And then I'll draw, say, a rectangle. I'll draw a circle. And I need to turn that into a polyline. So entities to polyline, I'm going to make that a polyline. Now, a couple of things. When you say across gaps, if you tried to shrink wrap this using across gaps, let me change the colors here so you can see what happens. So if I say do this across gaps, with shrink wrap, across gaps, and let's set our reduction to high. Say okay, and we'll do this and see what happens. So you see it goes across the gap, but it reduced it down. If I said no reduction, it does this. It goes across the gap and just goes all the way across it. Now what happens if you look, well, they used to do it, it doesn't on this version. Yours might say it. You may see in the echo, in the command echo, you may see inserted so many triangles. So it's actually triangulating this data in memory. And it's asking you, how much do you want to reduce those outside triangles, the perimeter triangles? How tightly do you want to reduce it? And that's what gets rid of those things. So if you look at that one, and I'm going to change that color to show you that original. So comparing that to high reduction, And I select all of this, but I need to unselect that. So now this one is with the so it follows the red, except it knew that was too much of an outside triangle, so it reduced the triangle, got rid of it, and then just drew the outline for it. Okay. So that's what the perimeter reduction refers to, is reducing the amount of outside edge triangles automatically. Now, if I do this as shrink wrap, do one more. Polyline here. If I say draw shrink wrap, bounded line work only. Now watch what this does. I don't have the option for reduction because I'm not doing any of that. I'm just going to say, okay, consider all of this and draw the boundary, which is this one. So you see it went until it found a closed area and then followed along that. So it looked at this, but it's outside in the open, but it followed around that edge, hit the circle, came around the circle, hit the other bounded edge, bounded edge, bounded edge, followed all the way around. So that's a really good way. Let's say you've got a couple of things that are drawn, maybe let's get rid of these open. So let's say you've got some things in your drawing and these are phase boundaries. This is phase 1, this is phase 2, this is phase 3. And you needed to see what the total combined area is. Well, you can add these up and subtract this out and all that kind of stuff, or you could simply shrink wrap it, bounded line work, select those edges, and now that is the overall outside in boundary, and it has an area over here that you can then work with in your on your properties. Okay, so that's how that works. Now the other command that I wanted you to be careful of is this boundary polyline, because we've been talking about boundaries. We're talking about surface boundaries.
Yep.
But a boundary polyline works differently. So if we do that and we pick in here, it's just as if I had done the hatch command and took the boundary of the hatch.
Right.
So it finds the boundary that encloses the point you pick, not the outside boundary in. Okay.
Yeah.
So that's how the command works, and you can use it to just generate line work. It doesn't have to necessarily be done with surfaces. But in
Is there a difference between doing that and just doing the normal AutoCAD boundary command?
You say what, just boundary?
Yeah. So
No, this is something I'm not aware of really.
So if you click the button right there, pick points,
Yeah.
And then do the same thing,
Oh, yeah, if I do this,
yeah,
yeah, that is exactly that same command.
okay,
Boundary. And if I say pick points, if I just pick that point, and there it is. Yeah,
okay.
That's exactly the command that it's called. What's it called? B poly or something.
Yeah, bound right polyline.
Yeah, so, and I can see what that is under my draw boundary polyline. Yeah, it's bound PL is the command they use, which is their version of it, but it hands it off to AutoCAD's whatever that B poly was.
Yeah.
Yep, that's exactly the same command. All
Okay.
right.
All right.
All right, so now I'm going to come out here and get rid of, I got some stray points. points out here. I don't know why I keep getting these straight points out in here. There's something that may have triggered it. I don't know. All right, so, and again, when you choose that, you could also choose to draw this. I'll turn my snapping off, and I could just say, all right, I want to go from here to here. Here, quit. Why is it doing that? Why is it? What is this on? Selection cycling. Turn the cycling off of it. All right, just go to here, to here, to here. Maybe I don't want to look at those points out there. I'm just going to come across like this. Come down, come in here, come across here, and then up to here, and then close. All right, so I could do that, turn that into an arc and snug it up like that. And as long as that's drawn, when I go to triangulate and contour, I can say, I'm going to uncheck my draw. I'll call this one EG with boundary. Whoops, boundary. And now I have to turn this on to use inclusion and exclusion areas. So when I do that, I say, okay, and it says now select objects. Well, don't get complacent and think you're going to grab everything again. Read the line above it. Oops, I hit too many enters. Write the file, use inclusion. There we go. Now I say, okay, and now read the line above it, select the inclusion perimeter polylines. Notice it's plural. You can have more than one.
Yep.
So I can just model here and leave the stuff in between undefined. So I'm done with that. And it now wants me to select any exclusions or enter for none. So I accidentally hit too many enters. But I could have picked like building outlines for exclusions, and it would have knocked holes in my surface for those. That would be really what I should have done.
Yeah.
Now select all my data. Now, even though this data out here exists, oh, let's see, I forgot. I need to turn back on my break lines. Break line right there. Okay. Now let me fix this. All right, so I would pull this down to here and maybe get rid of this one. Pull this guy back out to here. This guy out to here, pull this guy back. Something like that. And, you know, even though I still have data out here, I may not be interested in or care to use that. So I'll use that as my boundary. And I would say, triangulate and contour, EG with boundary, say, okay, yes, okay to overwrite. Now I select my inclusion, select any exclusions. Now here's where I could pick those building outlines. Well, that's a slag, it's not a building. Here, there's a canopy, which I think is just a canopy, so they got points underneath it. I think that's all. There's always one I forget to get. Maybe it's that one. Okay. And now select the data to model. So I'll say all. Built my surface. Again, I've got that head wall. And when I look at this surface now, there's those building cutouts. You see the perimeter has now been reduced. It's been trimmed off. And that would be what I would consider using as my design base.
I would verify some of this information here. It looks a little bit suspect, but but look how nicely that pond thalweg is, the stream coming in here. It's got the thalweg and the pond edges are nicely defined. So I would live with that. I could also turn on my contours to C, and I could set that up to 2 feet or. So this is just on the fly contouring. I can take a look at what they look like, see if I'm happy with them. I could look at my triangle edges, and again, I can make edits to this and save it, etc. All right, so I'm happy with that. Now that was just manually drawing this, but one of the things that you could do is if we triangulate and contour, and this time instead of using that, we're going to let it do shrink wrap perimeter reduction. If I say none, low might be a little too choppy. Medium might be a little better. I would try it and see. I'm gonna go to my setup button. I'm gonna turn on to draw it. I'll just draw a 2D and I'll put that on that break line layer. Now yours has this option, I presume, this shrink wrap.
One moment.
Triangulate and contour. I don't remember which version they added that into it. It might.
Does, yes, it does.
Okay, so this is a way that you can have it do it for you automatically. You don't have to go about drawing it ahead of time. But again, there's nothing, see, it's now asking me just to select the things that I want to use. So I don't get a chance to use the exclusions, but it will create, and I told it to draw shrink wrap boundary, which is here, and you see that reduction. It's snugged up pretty nicely here, but there's all these little jibber jabbers and all that kind of stuff out here, which you may or may not want, you may not care, it may be fine.
Right.
So you just have to, maybe your work is all down in here and you're not all that concerned out there. So, don't make more work than you need to make is what I'm getting at. But again, if you wanted to fix some of this sort of on the fly, I would go to that toolbar for polylines and erase polyline vertex. And I would just, pick a bunch of points in here to get rid of. Maybe that one, maybe that one. That one, that one. So you can modify your way around it. Go back and retriangulate and use the resulting edited polyline as that inclusion, at which point you would need to turn this back on to use the inclusion area because you've modified it and that's the one you want to use. Otherwise, you could do it or change this to a low reduction. Say okay, select everything. And now you see this one is not nearly as choppy as it was before, but you've also got this where you might want to snug that up a little more, so like that. Okay. So anyway, and every way that makes sense. And again, in that case, I wouldn't have bothered to have done that because I may not be working over there. I wouldn't care. But in every case, I'm going to look at this stuff over and over and over again in my 3D viewer, both the data that I use, and I look at the surface, and I can even select the data, go into that viewer with everything drawn, and then also go to model and add the surface. Now it comes in the colors a little garish here, so I'll go back to my view control. I'll turn this fill in off and back on, and it sets it back to the right color. And you can control that color over here with your surface properties.
Okay.
You can set the color. You can even apply a texture, you know, if you wanted grass or something like that. You know, that kind of stuff. I'll just say, go back to the color. So now, when you're looking at it this way, you can really get in tight and see to make sure everything followed the lines like you like it. There's those curb edges, and those are wedge curbs, so they are modeled correctly. However, supposing they weren't wedge curbs, maybe they were square curbs, but the people didn't. They only gave you the face of curb and the back of curb, and you need the top of curb, which is nominally 6 inches high right here,
Right.
directly above it. But you're going to have to set it back a little bit because you can't have those vertical edges.
Yep.
So you would do that, and we'll get into some of that stuff more tomorrow. But you just do that with a 3D offset, and that's on the edit. 3D polyline, this offset 3D polyline. It's also on, I don't see it on this menu, but it's on the,
Yeah, it's there. About a little more than halfway down.
oh yeah, you're right here. And there's also, it's on the toolbar here, and it looks like the offset icon from AutoCAD, but it has a Z next to it. If I can, it's on my Elevate toolbar, if I can find it. What is it? That's Elevate. I don't see it. The IntelliCAD version has it on that toolbar. I don't see it on this one. If it's Elevate. I just turned on view. Where did it go? Right here. Well, it's supposed to be on that.
On the Elevate one.
Yeah, see that icon right there?
Yes.
That is normally on the Elevate toolbar under the IntelliCAD version, but I do not see it.
It's on the polylines toolbar.
Oh, yeah, right there it is. Oh, good eye. And that's really where I would have expected to see it more often than not. So that might be a change for 2022. It used to be on Elevate.
Okay.
All right. So anyway, you would do that to set up that line. Like if
Like a tenth of a foot or something.
yeah, we would say do that command by these methods. It's an interval method. And you're going to change reading the prompts. My horizontal offset, I'm just going to say 0.02 and my vertical 0.5. And I would pick this line, I would set it back to that side. And now I've got, let's get these and look at them in 3D. And you can see there where I put this line in here and it's not over here. See, I didn't put it in over there. So, you know, those are ways that you can do that. And that's just like your stepped offset in Civil 3D.
Right.
Okay, and so, but that's the basics of what we're going to be doing. But the key is to look at that stuff, view it in 3D, do everything that you can do to make sure everything is the way you want it to be. And like I said, sometimes when you wind up with a surface and you view that surface, and sometimes it's just, let's say we've got a, you know, some kind of a, I don't know what that is, but you know, maybe that's really whatever this point was that caused that little thing to go around them. That's a legitimate point, but sometimes you can't really go back and find stuff. As long as you go into the viewer by the surface viewer, when you choose the arrow icon, you've got these point, you know, the 10 file edits that you can do. And you see it makes real-time changes to the contouring if you've got your contour shown, so you can, you know, maybe fix some issues that you know shouldn't be there.
So this is a little bit different than just editing the triangular mesh, I guess.
It is, it's a convenience. It does the same thing. So if I exit that, I'm not going to save the changes, but you've got under here your add point, all of these things, or you're going to go to your surface manager. We'll choose this, set it current. And then if we edit it, it draws the triangles for us. And we can come in here and now down, if your version has this, to choose the method of what you want to do. And you see there's a few more things.
Yeah.
If I remove a point, remove this point, that you see that, and everything redraws in real time.
Yeah.
If I swap the edges, you know, so if you're used to doing your edits that way and you like to do them that way, well, knock yourself out. But again, I like to go through and find out what caused that to happen in the first place and fix that and rebuild the surface.
Yeah.
So, you know, if you do that, you say, okay, and then you can choose to save it if you wish or whatever. And you can also look at the history. So this is let you go back and step back through those things and either remove it or whatever else you want to do. So now I've saved those changes with that command. So that's a little bit more of a command interface. And that is from the Surface Manager. And you also can do, like, if you want to remove a point, it does the same thing, it brings that same issue up. You got all these different choices. You don't have quite these same choices in that other, in the viewer, where if we, I'm going to go back to this, look at my history. All right, so that now has put things back to where they were. So if I do that through my viewer, I've got these choices.
Right.
And there's an undo in there as well. So if you do something, you can undo several steps back and all that. So that's sort of a convenient sort of mini toolbar for you as well. And again, I don't generally work that way. I generally work along the lines of what I told you is I fix the data, rebuild the surface. Just because, really, the reason why is because the surface editing tools weren't that easy to use. And they weren't that readily available back in the older days, and we had to do it this way. And because Carlson built surfaces so quickly, I was able to do that. And I didn't have a means in Carlson of using those edit histories.
Right.
So if I had to add something else to it, then I had to go back and redo all those edits. So that was a little too difficult to do. That's why I never got in the habit of doing it.
Gotcha.
But all of that's fair game, you know, any and everything that you want to do with it.
Sure.
So, all right, so now, tomorrow we're going to take a look at some of the grading stuff and how we interact with different surfaces, how we merge different surfaces together and all of that. And we'll take a look at the road design. We're not going to get into any super highway design stuff or like networks of subdivisions, but we'll do, you know, some simpler things, and we'll do some intersections and all of that, see how road net works and how that applies. And we'll sort of flesh out the rest of those civil tools. Okay.
All right. Sounds good, Ken.
All right. Any questions that you come up with tonight, jot them down. We'll go over them tomorrow. Anything that you may think of, pop me an email if you need to look at it further. I would suggest to, you know, take your head out of this tonight. Don't spend any time trying to do any homework, because you're just gonna, you know, it's like drinking out of a fire hydrant. It's a little too much.
I got it.
So,
All right.
all right. So with that, you can save this file. We'll work in it a little bit more tomorrow, but we're good to go for that. And let me turn some things off here. I'll stop the recording.